And what I forgot to do, and it was setting the thumbnail. I made the thumbnail, saved it to a directory, and then I didn't upload it. Derp. How's it going? Hey, Madam You, how's it going? How we doing? How we doing? What are we doing? What's up? What's going on? There's Twitch, and then there's YouTube, and operation stuff. Big Funny Giant, how's it going? OTT playing, and then there are the YouTube comments here. Okay, cool. All right, I've got all my windows open. God, it takes a bit. It takes a bit to get all this stuff up. It's the list grows as we get more stuff, and I should probably work on scripting some of it. I know that I could probably get the Stream Deck to open everything up on it on this computer, so I can just hit one button and be ready to stream. Of course, then if anything changes, it all goes to hell. I moved everything, and then I ran out of PCBs, and I didn't have a big enough PCB to house the whole circuit. And then I worked on it a little bit, but then I didn't work on it yesterday, so we got to jump in and work on this thing. One of the new features, I think, that I would like to add to this is to have another transistor on it, and that one will attach the low current, high voltage to the capacitor bank, so that there's a transistor between this power supply and the massive dump that will happen through this coil. So I'm going to isolate that. I'm going to put, even though we're still using the shutdown pin, we'll turn off the shutdown pin and then open up the transistor. Don't give current to the transistor. And then that will isolate the high voltage from the rest of the circuit. I was told that it's kind of useless to have op amps in a circuit like this. We kind of Googled around a little bit. Whenever we're using op amps, the prevailing wisdom is always just don't bother. It's not worth it. So I'm going to use a transistor switch. And the schematic is going to look a little something like this. Basically, the ESP is just raw dogging the entire rest of the circuit. But we're going to have this 5551 transistor, which has 160 volt breakdown voltage. So this will cut off here or go to zero. I don't think we're going to get current through this way. I don't think that's possible. But we'll have to see. Because if that does happen, we're in trouble. We're in big trouble. In which case, you could maybe put an op amp in here, something, something that can take it. But I think primarily we're going to be going this way, and so this will go straight down into the rest of the circuit, charge up the caps, and then this will cut off so that there's no flow going around here. Its breakdown voltage, I think, is pretty high. I don't think it's exceptionally high, so there may be some risks of like a foul loop coming along. Why is there an ad in the middle of this? What the heck? No. No. They put ad breaks in the middle of this thing. I'm gonna have to go to Firefox. There wasn't even a marked. That wasn't even marked. That was just like YouTube deciding to put an ad in. I guess all my ad blockers have broken. Chrome wants to update. Yeah, we're gonna have to turn this rig over to Firefox soon. Nobody's around. Where's everybody? They're all watching pre-roll ads. That's all we do these days. We are just creatures that devour ads. Yeah, so this is the big guy. This is the TIP 122. That's a Darlington, so it's able to take the huge amount of current that the capacitors will put through that coil. And then this will not present any sort of a circuit element. Hopefully not doing one of these, because that would be very unfunny. Let's look up the 5551 and see what it does. I found the 5551. It was just in a group of stuff that I have. Here, other 4-pin photo transistor, but these aren't necessary apparently. 2N5551. General purpose high voltage amplifier and gas discharge display drivers. Gas discharge display drivers. Wait, is this like a Nixie tube or a VFD transistor? Oh, that's kind of cool. That's kind of cool. I like how ammo can is apparently like an industry term. 160, collector base voltage 180, collector emitter 160, collector base 180. Emitter to base voltage 6 volt maximum. EB. Okay. Well, we're giving it 3, so 600 milliamp collector current continuous. Our current's going to be a lot more than this. Well, no, 600 milliamps. That's right. The 100 volt power supply is 80 milliamps max. So this is well within its ratings. But what about collector base leakage? Well, the breakdown voltage is huge. 50 nanoamps. Is this going to put another add up? What are you doing? Drift in Hilbert space. The name of the song. Collector emitter saturation, DC current gain 80. Base emitter on voltage is 1 volt. We're good on that. Small signal current gain, noise figures. No mention of leakage. I don't remember this song. I guess that's right. Saturation versus collector. Base emitter voltage versus collector current. But that's on. I'm looking for. I don't know. I think if we use this in the circuit, it'll be good. It'll be the surface mount one, so it's not like it's not going to isolate it real estate wise, but it is going to electrically turn off that line, because there's like 9 volts hanging on this line, and so I don't want that 9 volts getting out of the 100 volt regulator when we hit the enable thing. So we hit the enable thing, and there's going to be like around 9 volts here just sitting on that line, and that'll keep us from charging the caps up to 9 volts. Unintentionally. But my concern is this is a 3.3 volt ESP. So if we get anything coming back on these lines, we're dead. I think the tip 122 is good for it. I don't think that's going to leak. It's this 2N5551 that I have some concerns with. This is not a complicated circuit. It's actually quite easy. I'm just being a little extra about it. And I want it to be clean. I want it to be on the stuff and clean. So I've resoldered a bunch of stuff. Still need to do all of these output connectors and put the 5551 down here to supply the coils. But I think I've got all the equipment down on the board. Got a LM1117 5-volt regulator. This is a sour spot. This right here, this voltage regulator. I put it as far to the edge of the board as I could to try to minimize the amount of space it took up. But I found one that it didn't have like a crazy layout like the 1117 has. 1117 is happy to get 12 volts in and turn it into 5 volts all day, right? But when you get up there with the current requirements, it'll start to kind of chew on the power a little bit more, which I wonder why. I mean, the instantaneous current draw that we were observing on our power supply reached like 2 amps out of the 12 volts. Gotta mute these stupid. My ad block broke. Get back to the music, stupid ads. Anyway, so what was I talking about? The LM1117 gets kind of hot under this application. We had a little bit of trouble with the previous circuit. It might have been a wiring mishap on my end, but it was able to draw a lot of current suddenly, and it was really only the ESP was sitting on the line. Everything else is going through a 5-volt regulator to other portions of the circuit, so I don't really know where all that current draw came from. But it hit 2 amps a couple times. So I'm like, all right, well, maybe I should put a bigger voltage regulator on it. And I was looking through what I had, and I had a 1.5 amp, same package, but with a layout that made more sense. It was the in, ground, out, whereas this one I think is like in, out, ground. Very strange. But that in ground out would have been perfect. I could have put a big chunky thing up top on the heat sink, and then everybody else bleeds out the ground with all the heat, and I would have 1.5 amps for the rest of my circuit. And I put it down on the board, and I put the board down like this, and I said, all right, well, if I'm going to solder it, I did. I soldered one lead, and then I unsoldered it because it like moved. It wasn't perfect. So I was like, all right, I'm gonna put it in the vise to get it perfect. And I fumbled, and the voltage regulator bounced off of my knee and vanished. It's just gone. It's not on any of the magnets down here. Not on any of the magnets. It's just gone. It hit the floor, and it went under something, and it's gone. I was so mad. It was the only one that I had because it's just like scrap. It's just extra stuff that I have in the shop. And it just vanished into the ether. It is in the cat dimension now with a bunch of left socks. But my palpable disappointment in myself for having fumbled that so badly. God damn it. So mad. You can't win them all, and the floor claims its victims without emotion. Oh, I need to kick the fan. I need to kick the fan, and that's not a turn of phrase. I mean, I literally need to kick the fan. I'm not trying to, like, speak in euphemisms. I'm literally kicking the fan. Is there a voltage regulator here? No. No, it's somewhere. I don't know where it is. I'll find it one day, or maybe just I won't. Maybe I just won't ever find it. It's just gone. It's so annoying. Oh, I'm so mad. All right, anyway, let's bring this over. Bring the light over. Give us some light over here. Oh yeah, and then the thermals are frozen. Let me unfreeze the thermals by actually powering them up. Power on. Thermals. Off. And then on. Oh no, it's still frozen. I need to restart the source. Yep. Ooh, it's going to be weird until it calibrates itself. Ooh, weird. It's super weird. And it's back. Oh no, it's still weird. Ah. We'll give it a minute to figure out what it's doing. Yeah, sometimes it inverts colors for some reason. It's just one of the weird things that the thermal camera. Something weird in the code. What's up, Walrus? All right, let's turn it off and on again. Boop. It's frozen. It's back on. And then I hit properties and I deactivate it and I reactivate it. And then it's and then it's fine. What the deactivate? Activate again. There we go. Now it's good. Now we get our brilliant little thermal images. I was just saying, I dropped it was a 1.5 amp voltage regulator that would have been perfect for the circuit. I dropped it and it vanished. It was an absolute tragedy. I was very disappointed in myself for this little switching circuit that we've invented. I mean, this is all well and good and fun, building this, getting this whole circuit scheme together and putting it together because it's so simple. It's literally just switching a thing. But I've overcomplicated it and I've decided to make it as neatly as possible. So I need to go back to the drawing. I had to go back to the drawing board with it. What up, Ace1234? Finally, someone to watch. Oh, is it a quiet Friday? Why did it get so quiet? What's going on here? Where's my... This is just quiet between songs. The ad people have gotten to me. I think they disabled all of my ad blockers, so looks good. I hope that I am not going on bad assumptions with this right here. The 100 volts will sit at 9 volts between firings, so I want this here, and then I'll activate that separately, so this will get activated, and then we'll have the cap charging loop. But when it's deactivated, I want it to be isolated from the massive current draw through the coil. That little guy's going to get hot. This is only 80 milliamps. 80 milliamps when it's at 100 volts. This is just for charging the capacitors. This is the big hit. This is the like 5 amp hit. But that'll hit through the capacitors and not, this power supply won't get a sudden current draw from having that coil on there. That's the thought anyway. I hope that works. Because I can hit the disable pin, and that's what we've been doing, is hitting the disable pin. But with the disable pin hit, we see it floating at 9 volts. And that may, 9 volts, that's just a little battery, but it's a little battery on 3 massive capacitors. So even at 9 volts, I think that's kind of a sizable amount of energy stored up. So I don't want this to trickle in 9 volts when it's off. Instead, I'm cutting it off. And then we'll only apply this for the, what was it, like 80 milliseconds before firing. And that way the needle will fly up and then click, and then the needle flies back down. And then we're changing this, the flyback. I've heard of people using flyback capacitors, which is fascinating to me. Because what would happen? You would hit this with a massive amount of current going this way, right? From positive to negative. And then the coil, which has built up a bunch of energy, would want to fly back in this direction. So instead of that, you add a capacitor, and then the positive charged capacitor negates the negative spike, and your magnetic field dissipates. I don't understand. I feel like it would just contribute towards this. And reverse voltaging a capacitor, as we saw yesterday, or last stream, those caps were heating up quite a bit. I want to look that up. I want to see like an equation or something, see if we can't. Flyback capacitor. I need to get back to doing the musical circuit soon. I haven't worked on those in a little bit. So in conjunction, the flyback converter is used in both AC/DC and DC/DC power supplies with galvanic isolation between the input and any output. Flyback converter is a buck boost converter with the inductors split to form a transformer so that the voltage ratios are multiplied with additional advantage of isolation. I'm not really concerned with that. These are just flyback converter, not really a flyback capacitor. So optimize the ripple. Flyback transformer. Schottky. Yeah, well, we need to find a Schottky diode to go in here. I have a little kit of diodes, though, so we should be able to find one pretty easily. Schottkys are apparently better at flyback for some reason, just because of their the nature of their switching. Interesting. Does this motor driver need a capacitor? Oh, this is going to dox. 1 sec. Stop doxing my emails. $100 nanofarad directly across the terminals on each motor help filter out some high frequency noise. Whatever. Okay, anyway, let's not get bogged down in that, I guess. Let us not get bogged down. Now, Gonad supposedly redeemed a fart in the middle of the night last night. But I don't remember hearing it. Possibly because I was dead. If I redeem one, let me just check to see that it's on. Where is that? Fart number 2. Oh yeah, okay, it still works. It always works. It's always on 24/7. I could add one of these things like this, the is stream live detector. We eventually got this working. So maybe if chat actually gets going here, if I actually get viewers, which I probably won't because I didn't stream on Thursday, and you lose a lot of momentum when you miss days like that. I was not up to streaming. I am sorry. I woke up in a bad way, but I'm fine now. Totally fine now. Feeling great. Feeling good. I think I'll go for a walk. Yeah, I know, but it sucks as a streamer because like when you don't show up, nothing happens, and then people kind of dissipate. Like you build all this momentum to build your little like sandcastle, and it just washes away if you don't stream. It's one of those things. It's why people get real stressed out doing this kind of thing. Yeah. But it's what numbers still recover. It's just today is going to be particularly slow, I think. And and I'll try not to bitch about it. I know I complain a lot about this stuff. It's all I have to talk about. I'm that boring. It's so boring. No, it's not boring. We're gonna do fun stuff with circuits. That'll be interesting. The other thing I was gonna say. Oh yeah, so Djibouti Show started playing, or not started. I guess they started a while ago, but Def Jam Fight for New York, and it reminded me of how much I played that game back in the day. Oh my god, that was a flood of memories. I was like, wait, I remember the Danny Trejo fight. It's super cheap. It was fascinating. It was a whole bunch of memories that I didn't even know I had. Oh, I can do this right now. My red LED thing broke. And it broke by this tab is gone. It's just gone. It's just not there. And I have a couple of red LEDs. Oh my god, this is one of the ones I spilled coffee on. Ugh. Is that a Mogus cave paintings in there? What have you guys been up to, red LEDs? Well, I've not been watching. Nefarious shit. All right, let's get these in a new can. Oops. Well, some of them got around. That was not the most efficient way to do that. Now I have 75 red LEDs out on the desk here. All right, that one's garbage. Doesn't hold anything anymore. It's one job that it has. I think the heat is on in here, man. I'm not gonna have a good time with the heat on and all these lights. Now I could add LEDs to this circuit. It's always fun to do that because then you can see it doing its job. But I guess, oh god, this is a risky maneuver. But I didn't want to spend the time putting LEDs in. Just because it's hard to get results with this kind of stuff, and I wanted to have something to show for it at the end of stream. I dropped a bunch of these. A bunch of these went, oh god, what the fuck? So that's one problem with these bins is that, look at this. I put it hard up against the side of the table, and a bunch of them decided to drop perfectly in the middle where there is a notch in the bin. Did I just lose that one? Yeah, that one's on the floor. Okay, they're not worth scraping up. Good day, sir. What's up, Last Miles? Yeah, see, a bunch of them fell in there. Stupid. Ugh. So nothing with those high power caps. Yes. I took the circuit apart. I'm putting it together again differently. We've been working on this for too long, but it's just one of those things where I'm not going to be able to sleep at night unless I optimize this thing properly and build it neatly. I don't know how neatly this thing is going to go together, but the whole conversation that we had last time on op amps not really being necessary or useful in the application is the way that I had them. They're not really doing much because there's not full isolation. So I might as well just throw my ESP in the fire and put it in the middle of this circuit. So what I'm doing is I'm going to add this 2N5551, which apparently is used on VFDs and stuff for switching sort of high current. I just randomly found it in my book of my binder of transistors, but it's a high voltage. It blocks about 160 volts and it works at those voltages, and then it's activated by about a volt. So and a couple milliamps. So the ESP is going to hit this with 3.3 volts, and hopefully this circuit here doesn't feed back much back into my ESP. And that'll allow the 80 milliamps at 100 volts to come in here and charge the caps. But then when I cut this off, it won't slam all that current requirement down on my power supply, my measly little 800 milliamps. Plus, I saw a quiescent of 9 volts on that line, and I kind of want to cut it off from the big capacitors because that'll eventually store a whole bunch of energy at 9 volts. So this will cut it off, and then this will slam down the tip 122 and do its job, and then when it's time to charge it, I can activate this again, and it'll put 100 volts back on the line. That was a discussion regarding electrical engineers types that claim what is correct and not, but it looks like you have not burst the lab into flames, and therefore this is progress. Yeah, I guess the lack of flames could be seen as a good or a bad, depending on your perspective. Like, for instance, if you're sitting in this chair, it's nice that there aren't flames. But if you were sitting behind your computer watching somebody sitting in this chair, maybe it's not so great that there aren't flames. There might be a very loud noise and a little bit of smoke coming out of that transistor, but I think we should get away with it, considering going over the data sheet, it seemed to be meant for high voltages. So have another quiet, slow day because it's Friday and everybody's probably either scrambling to get work done or to hide the fact that they're not working and therefore are not opening up Twitch and watching random stuff, or they're just watching gaming streams. You guys are wasting your time on those gaming streams. Waste your time over here on an engineering stream. But yeah, we got a plan. I meant to have this done by today, but I'm me and endlessly professionally procrastinating. So we're gonna build this today. It'll be a Friday stream where we've got a complete purpose and we know what we're doing. Because I don't have anything to take apart. I don't got nothing to take apart. Oh yeah, what's my pinout on the 555? Oh, it's right here. Okay, cool. Base emitter collector. Why do they do it that way? I guess because sometimes you do base emitter resistor, and that makes it easier to do. I don't know. Our base is going to be isolated, though. I'm not going to have a pull-up on it to 100 volts. Hell no. Hell no. That would be hilariously bad. Oops. I closed everything. It's nothing anymore. There's just nothing. Other than that, I'm doing pretty good. I was watching Groovy Something racing cars last night. Sim racing. Gonad initiated a fart in the middle of the night that I didn't hear. Or maybe I did hear it and I just don't remember. Must have been the wind. Farting. Wait. What if he was a chatter and you said start soon? It's petulant. And I want more things that do that. If you say it multiple times, it's not gonna mess anything up because it's got that little filter in there. That little filter block makes it so easy. I only wonder if I can do a profanity filter. Node red profanity filter. Node profanity filter. The bad words package contains an isProfane method to test. It allows you to replace bad words as well as define your own list. Neat. Did that not get it? That should have done it. I didn't notice it on camera. Yeah, I guess starting isn't... No, starting is one of the words. That should be fine. Maybe I just missed it. I probably just missed it. What are music? It's still gone. It's just quiet. It did it? Okay, I missed it. That happens. Okay, so 5551. Oh yeah, profanity filter. Watch your profanity. Let's not let it dox me. Please don't pop up. Ideal is not idea. I guess, no, but ideal worked before. It was off camera, though. You probably missed seeing it then. I don't think I saw it from ideal. But it should trigger from ideal. Save time securing your code using AI agents. Oh, Jesus Christ. As well as define from your own list. Okay, so I don't have to type a bunch of bullshit to list for non-politically correct words, but I can't seem to find it. Language.json. You have to implement your own. Read this. Scunthorpe. Oh no. The Scunthorpe problem is the unintentional blocking of online content by spam filter or search engine because their text contains a string or substring of letters that appear to have an obscene or otherwise unacceptable meaning. Ugh. Names, abbreviation, and technical terms are most often cited as being affected by this issue. The problem arises since computers can easily identify strings of text within a document, but interpreting words of this kind requires considerable ability to interpret a wide range of contexts, possibly across many cultures, which is an extremely difficult task. Throw AI at it. Sorry, I threw up in my mouth a little bit. As a result, broad blocking rules may result in false positives. Yeah, I've seen the thing where somebody's name is not profane at all, but when you star out the middle of the name, it looks like somebody is saying something extremely profane. They're like, why did you do this to me? Peniston is my favorite town. Yes, I'm from Peniston. We're big fans of pens. We got Penn Island over there at Peniston. Problem is named after an incident in April 1996 in which AOL's profanity filter prevented people in the English town of Scunthorpe from creating AOL accounts because the town's name contained the substring cunt. In the early 2000s, Google's opt-in safe search made the same error, with local services and business that included the town in their names and URLs among those mistakenly hidden from search results. The Scunthorpe problem is challenging to completely solve due to the difficulty of creating a filter. That's a weird statement. It's actually not that challenging anymore. We have much more complicated systems that can do that kind of stuff. It was difficult back in 2000. Understanding words in context. AI is, I guess, all about that context. One solution involves creating a whitelist of known false positives. Any word appearing on the whitelist can be ignored by the filter, though it contains text that would otherwise not be allowed. Refuse web domain accounts and registration. Jeff Gold attempted to register shitakemushrooms.com, but due to the substring shit, he was blocked by an internet filter prohibiting the 7 dirty words. I hate the 7 dirty words so much. These words are horrible and should be kept from you, and blah, blah, blah. It's, yeah. Yikes. Part of burn the subs is sort of the circumnavigation of these sorts of rules. BTS is sort of all about finding weirdos on Twitch that have made these names and bringing them to light. It could use a little bit of work. I definitely need to work on this. I'm trying to carve out a little space for burn the subs. Now that we've sort of got the back end working, right? The regex from hell. Oh, I still to this day I cannot understand regex. We've worked extensively in regex with burn the subs, and I just can't. Address validation. Addresses of Perl to validate email addresses according to RC822 grammar. It provides the same functionality as blob address Perl regular. The module is much faster to load, doesn't need the grammar at startup. This is not a regex that humans can parse. This is insane. I'm sure some of you eggheads would be crazy about this kind of thing, but goddamn. No! Silence ads. Sponsor, 1 of 2. What the fuck? Get the fuck out of here. There we go. Sorry, my ambient music broken up by advertisement is the worst. This would be the regex for that purpose. Do not write the regular expression by hand. It's generated by the Perl module by concatenating a simpler set of regular expressions that relate directly to the grammar defined in the RFC. It does not cope with comments in email addresses. The RFC allows comments to be arbitrarily nested. I don't even know what this stuff is referring to. This is crazy. No, I mean, I'd pull in some kind of a sensor node, I think is the best way. Bad words. As a version 2, it requires you to either have an environment that understands ES 2016 and beyond, or transpire like Babel. What? Yarn add bad words. Usage. Import filter from bad words. That's filter to filter. Console.log. Filter clean. Don't be an arsehole. Okay. Regex overrides. Ah, it's the dreaded regex, man. I have tried. Don't stare at it for longer than 90 seconds. It'll cause mental harm. Yeah, it's like an eldritch god. Much like the sun. If you expose your poor retina to it for too long, it's this unfathomably large thing in the sky that burns you if you're out in it too long, and you lose your vision if you look at it. It is an eldritch horror. That is what the sun is. It's millions of miles away, hundreds of millions of miles away, and yet it still heats our planet. Words to it. This isn't a node. This is Node.js, isn't it? Yeah, it's different from what I was looking for. Yeah, that's different. One day the sun will leave us. We all have to deal with that little existential dread. Node red node bad words. Here we go. A node red node that attempts to filter out messages containing swear words. Node red node bad words. Uses bad word npm to attempt to filter out containing swear words. Analyzes the message.payload and tries to filter out any messages containing bad swear words. The payload contains a bad word and the whole message is blocked. Only operates on string. That's fine too. I could put this on burn the subs and see if it picks anything. Last kilometers. No, hundreds of, how many millions of miles? At a temperature of millions of degrees. Sun is... I don't remember any of the lyrics of the They Might Be Giants song. That's how I would know. Speaking of words used carefully, I would think units of measurements based on a reasonable standard would be a good place to start. I feel metric is correct in all cases. It's just not the case. Blah, 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 blah. Aggressive blah, blahing. I'm going to blah over you. What's up, T. Kamowski? And Lawn Dog, how you doing? Today's thumbnail, one of our favorite amp meters in the picture. Yeah, I wanted to capture that because that's sort of the drama, is the 100 volts that this thing brings. I do try with my thumbnails. Although this one I started upstream and I actually didn't have the thumbnail uploaded. I went through all the trouble of making it and then I forgot to upload it when I went to start. The more and more tasks are piling on the start of stream. Get the lights working, get the cameras working, get this and that and the other thing, one thing after the other, then figure out what I forget once I go live. Things just fall by the wayside. Too many pre-stream tasks. And that's where the Stream Deck can swoop in and save the day again. Although that means that my dependency on Stream Deck will be even greater, which is a problem. To calibrate these cameras, it's a bunch of little busy work, and I put it onto the Stream Deck. So like unto that, what I could do is put the new web pages up on here, so it opens everything and puts all the windows in the right spots. I probably need to do that because it'll also remind me of the different tasks that I have to do, like opening the YouTube comments or the YouTube chat section, which for some annoying reason is always at a unique URL. It's the same URL for one stream, but the next stream will have a different URL. So it's like I don't think I have a tool that I can direct to like click on the page in a particular place and then pop out chat. It's very annoying because Twitch chat is always the same URL. It's always twitch.tv/popout/o_bother/chat ? Popout equals. That's always the URL. Get out the door and pick up parts that landed at the FedEx office. For some reason, I have to go get them, which is always fun. They're just not comfortable putting it in a delivery person's arms because they're radioactive or something, right? Is that what's going on? they're making like noises and like growling. All right, so relatively easy circuit to build. I just wanted to make it neat and add and subtract some items from it. It's going to be a little bit smaller because I ran out of big circuit boards. Either the huge circuit boards or slightly larger. It's really annoying. I decided to redo it. I decided to start from scratch just so I could neaten it up a little bit because there's less stuff now in the circuit. Yeah, I've always wanted to play with that. Have my own RNG source. I mean, I could, now that all that stuff is in Node-RED, I could just scrape it off of the random.org. That's actually not that hard to do. I was going to do that with the YouTube stuff, is go through HTML and see whether or not any of the indicators are on the website that says if you're live or not, and that way I could put it into the on-air light. So the on-air would have the YouTube monitoring capability as well. That's actually pretty important because I had a 4-hour YouTube stream where I accidentally left stream on. I hit stop streaming on OBS, but then the YouTube plugin that I use, the Chinese YouTube plugin that co-streams, it's not really built into OBS, so it kind of can keep broadcasting if I'm not careful. I have to hit 2 stops. I have to stop over here and stop over here, or else I continue to stream to YouTube. It's bad. I need more automation. I need more automation. I could probably find like an online tool that would do this, but I appreciate having all of my stuff sort of contained within my own setup. It's not dependent on external things. I can't say Streamlabs is down, I can't stream today. Instead I go, I'm stupid and I can't stream today. More automation, more locally controlled automation. Question that I have, where in the lab setup is required, is to compare the entropy and quality of Fortuna algorithm versus a real radiation decay source with a reasonable particle counter. I will ponder that over coffee. Is there a predictability in your own radiation? Yeah, I don't know. I don't know. But for me, the reason that I do the automation is because I forget stuff. I'm just a person. And it would be nice to have just one button you hit and everything is ready to go. And then the other part of it is further automation would mean that on-air light can be smart enough to tell me whether or not I'm still on YouTube. And so I don't end up streaming for 4 additional hours of nothing. Because you can't even pull that into the editor. You can't pull that into the YouTube online editor. It just crashes. Or just lags because I'm so low priority. Sort of thing you could set up is certainly you need about $10,000 to begin. I don't, they're particle detectors that are pretty cheap with some DIY things. You would be stacking up a couple different DIY projects, though. That's the weird part about if you would get into your own radiation creation and detection. That does exist. There are those cloud chambers and stuff too that you could maybe use. I don't know. I don't know how random.org actually does what they do. I do not know. I know on Arduino, some of the additional random number stuff, you basically are using an antenna, which will have sort of a floating voltage level up and down on it. And you detect that analogically, and that can help seed your random numbers. I wonder what that means, like if you have a microcontroller that's starting up and you blast it with a bunch of EM, if it'll get predictable in any way. Wilson Cloud Chamber, heard about it. Have a lava lamp. A lava lamp is a reasonable source. Oh, that's, yeah, so that, who is that? That's some company. Has lava lamps on the wall, and they have a webcam on it, and it looks at all the lava lamps in order to create random. More true random. Have I tried the Arduino R4? I have not had an opportunity to try it. What's great about it? Let me look it up. R4, that looks like a serious Arduino. 27 bucks. Uno R4, and it's got a little heart on it, and LEDs. Get out of here with all this stuff popping up. I just want to look at what this is. So it's got an ESP, like a big one, powerful one, USB-C. Your normal inputs going into what looks like an 1117 style regulator. Lots of LEDs though on that grid. And then, don't know who the microcontroller is. Huh, that looks like fun. Cloudflare, there you go, that's the one. Craziness. No, I haven't had the opportunity. I don't like, might as well just stick an LCD on it. Yeah, if it had a little e-paper display. The traditional Arduino in its traditional package does not lend that easily towards the type of work that we do. Like if I were doing something on a breadboard, I can run jumpers over to the Arduino. That's fine. That's a great place for everybody to start. But I would rather have something that's a little bit more natively blocked out for the perforating prototyping board, or for the perforating prototyping board, or the solderless breadboard is really where a lot of our stuff exists, because a lot of our stuff is sort of a little bit temporary. Let's jump out the door, get parts, we'll stream later. Please get careful with those big fancy caps. Yes, I will. We'll make some big sparks, but most of what we're doing today is in the vein of not having a giant explosion. There's always the possibility, and if it does happen, maybe the clip will go viral. But anyway, the traditional Arduino is a wonderful little microcontroller. You can get this board, you can sit down with a cup of coffee, you can do just about anything under the sun, just by Googling a couple of things, right? And then writing a few lines of simple code. Don't ask ChatGPT for your Arduino code. You do not need ChatGPT to help you with Arduino code. Learning basic C is part of using tools like AI in order to bump up your capabilities, but you don't want to take that bump from the very beginning, because you won't learn certain things. But anyway, Arduino is easy can be. You sit down, cup of coffee, Google some sensors or whatever you've got on your hands, look for some schematics, maybe build the circuit, put it together, load the code up, bada bing. You've got a cool little project running. Going as far as to get the vastly crazy, complicated, latest and greatest R4 that's got all this processing capability and whistles and bells, we never really need to do that. Why do you use SMD components? Because they are more neat and more easy to work with. Through-hole requires flipping the board constantly. My first self-designed PCB was making an Arduino, so it's pretty easy. It's only like 6 to 7 parts, all through-hole. That's pretty cool. R number, I think it's Renaissance. I see the R in front of the number. Renaissance. Renaissance. For me, when we start with Arduinos, we're typically looking at something relatively complicated, and so I will start with a powerful microcontroller that just plugs in to the breadboard, and then we can scale it back when it comes to making the real thing. Although we almost never do that. What's the biggest SMD component size? Biggest SMD component size? It can get huge. I mean, you can get enormous SMD components. 1206 is the larger of sort of the resistor sizes. 0805 is what I typically use with this kind of stuff. 0603 is the last size you get before the components stop having numbers written on them. At least in terms of resistors. Shut up, ads. I gotta. Is 0204 still hand workable? No. Kind of, but not really. These are like 0204s. You can see the size there. Like, I could probably work with that, but it would be a major pain in the butt. That's 0603 with a number on it. The bottom one, this one here. These actually are 0402. Wait, they have an 0402 that has a number on it. That's unique. This is more towards 1206, although it's a little bit different. And This is, what is that? Oh, this little diode right there. I don't know. It gets all distorted when you look at it like that. It's hard to tell what's what. But you know what is what. This is 0805. That's 0805. That is just about large enough to bridge between the 0.1 inch plated holes of this board. Did the component have an Arduino logo on it? Which one? I think you crazy. You crazy. You crazy. You going crazy. This is an Atmel logo on it. Oh, the fuse? I mean, it's an 8. I don't know how much Arduino can really claim that they invented that as their logo. Possible that it's an infinity. I don't know. And this is an LM1117 again. So basic steps where I got a feel of the real estate of the board. I got things down sort of where I wanted them to go. It's a little bit more compact than I would like. I left a little avenue over here, and we've got all the room under the chip to run our transistors and lines and stuff. Probably want the transistors to be over here where the high voltage is. And then I just need to finish figuring out where the stuff goes, and then we can ground everything. Then we do our low voltage and high voltage lines. Then we do the signal lines, and that'll be our whole circuit. And if I do it in that order, and I don't skip around like I did previously, we can make sense of this thing, and it'll go together neatly. And hopefully by the end of stream today, we will have the circuit done. So I'm going to get started because we definitely have our work cut out for us. What's happened is I sat back from this thing and I said, Bother, what are we doing? And I said, why am I referring to myself as my online moniker within the confines of my own brain? I don't know. But anyway, what I would like to do is get this circuit built. I started over from scratch. I looked at it and I said, this is too sloppy and we don't need op amps. Apparently the internet was pretty rude about telling us that that wasn't a requirement of a circuit. Like apparently, unless you are throwing your voltage into some kind of a DC to DC regulator so that you have isolated DC, there's no point in having the op amps in there, which I don't really fully understand. I guess it would be the ground can lead back to everyone. I don't know, man. But so what I've done is I've started from the beginning, and I have a slightly altered schematic that is much more simple. And we will see exactly how many volts a transistor can take. Now, we will see whether or not I am huffing on a crack pipe or if this will work appropriately. What's going on here is I'm trying to isolate out this power supply. And there's no point in having that power supply at 100 volts just constantly chewing away, providing energy into these giant capacitors. Between firings of this coil at 100 volts, I don't need there to be a life-ending amount of energy sitting on these lines. So what I originally did was use the enable pin. And by disabling the enable pin, unfortunately, it left 9 volts sitting on the line. With 9 volts sitting on the line, these are big capacitors. These things at 9 volts is like a significant number of 9-volt batteries being connected at the same time. Not in series and parallel, but there's still a lot of current sitting on that thing. Like screwdriver melting current. Maybe not so much life-altering amounts of current. I mean, you can have like a 12-volt car battery and it's not going to kill you, but it will melt your screwdriver. So I don't want that exposed. So what I've looked at is my series of transistors. I have this sample book that's full of transistors, right? Binders full of transistors. I have this sample book that I bought of, hey, OctoJ, what's going on? How you been? Sample book of transistors, and I was looking through them, and I said, man, I wonder which one of these would be good to use. Hey, that says 555. That's funny. 555. Haha, that's the chip that I hate. Well, it turns out that the 2N5551 is actually meant for general purpose high voltage amplifiers and gas discharge display drivers. So like vacuum fluorescent displays, Nixie tubes, high voltage kinds of stuff that doesn't have a lot of current. It's perfect. That's exactly what we need. It can switch 600 milliamps and it can work up to 160 volts. Perfect. So I'm putting that in there, and that's in order to isolate out the high current part of the circuit from this. So when we're not firing this thing off, we keep current from flowing through this, and that will cut off our circuit and keep me from having, first of all, a high current draw across the high voltage supply, but it'll allow us to trickle charge those capacitors when it's time to fire off, and then take everything off of the circuit and boom, fire it off through the coil, which will then launch one of the millions of little plastic emotes that Wexo sent in at my face. I had a big ice storm last week. We were without power for over 10 days. Dude, that's, I guess, why we invested here in a generator, but we're close enough to civilization that, and I think the energy company has come through and really trimmed those, all the lines that kept knocking our power out. So we haven't had a power outage since we got the generator. It's ridiculous. Had to stay at my aunt's overnight as we had to take the train to Montreal the next day, and we're without power. Had my visa interview in Montreal. Damn, it's a lot to go through, man. You're sitting there like with stink lines coming off of you because you haven't showered in 10 days. Hey, can I get my visa? We had a generator with the whole house one. Oh, it was just like just to run the fridge and freezer. My buddy has one of those, and he just has a hookup for it under his deck. He just goes outside, starts the generator, and then plugs it into the rest of the house manually, which is crazy. So this is the idea, and this is the circuit that we're going to build. I guess it's down to me building it. My concern is that when this is charged with a bunch of energy, is there going to be any chance that stuff could leak back this way? I don't think so. But we are putting our ESP sort of right up on the edge of the diving board here. I really don't want, with the TIP 122, like there's a couple gates in there that are isolating it, right? The 2N5551 is just one. I think we'll be okay. I don't think anything's going to feed back over to our ESP, but I guess we'll just try it and see what happens. ESA approved. A year and 9 months of hard work, and the stressful bullshit is over. Hell yeah, brother! That's congratulations. More opto isolators. No, because remember how mean the internet was? They're like, you're stupid and pointless. And I'm like, thanks. Great. I really appreciate that. It sort of kind of struck a nerve, but okay. When we looked up op amps as isolation pieces, they were like, no, like that's dumb. You're dumb. Don't do anything anymore. Never cook again. Apparently, they're sharing grounds and we don't have DC isolation in the circuit, so there's no point in putting an opto isolator in there. But I mean, push comes to shove, if we blow up another ESP, then I can put opto isolators in here. Couldn't you put the food in an ice storm and turn off the freezer? That's what they do in like the Newfies do this in Newfoundland, where they have the giant ice, like this huge snowstorm, and they just open the front door and stick a couple beers in there. It's awesome. I guess if you're already stocked up for it, it's awesome. It's kind of scary if you didn't have stocks. Yeah, wild animal. You mean mooses, right? You just mean moose when you say that. You're just trying to. You don't need to fool us. We know you mean moose. So we got to build this circuit. I gotta get started. Meese, mooses and meese and occasional raccoon. I had to shave down this screw terminal, otherwise it wouldn't fit underneath the 100 volt power supply. This is kind of a special thing. This is like it's from like NixieTube.com or whatever. I have smaller, like 60 volt Nixie tube drivers that are a little bit better than this thing. This thing is an adjustable high voltage regulator designed for things like Nixie tubes, and it's got a huge capacitor. It's a big board. I figured it would be a good fit for this circuit, and especially because it has a shutdown pin on it as well. So we got this together on the breadboard, and it worked great. We were flicking emotes all over the place to the degree where my hardware setup was kind of bad, and I feel bad. But in the end of the day, when it came to moving it around the desk, things were connecting and disconnecting in odd ways because solderless breadboard is not a permanent solution. I say this on the end of watching a super fast Matt video, and I understand his sort of level of involvement with electrical engineering stuff is not the same as what we do. It's much more rudimentary, and he knows sensors to get data, and the data you can then use to do much better things mechanically. That's all well and good, and I know the setup was temporary, but he put a solderless breadboard on the roof of his car. In that scenario, and I've seen this done often too, where the project person will do their breadboard circuit, and then they take that breadboard and they put it in the thing that they're trying to build as if it were a permanent circuit board. That is not the purpose of breadboard. Oh my God, it's not. When you come up with that thing that finally goes in your car, you build it on perforated prototyping board, and then things are soldered and attached. And they aren't just a wave of the wand from disconnecting in unique and interesting ways that you may not even be able to detect. Like if the wires come out, where'd the wires go? Maybe they went here, maybe they went there. It's a solderless prototyping board. It's not prototype is in the name. Really, before you do these, even if it's a silly little sensor project, you really should be migrating that over to something soldered or whatever. It boggles the mind. And I know I say you can skip this step in a lot of different applications nowadays because of $5 circuit boards, but you know, if you want to build something that's temporary, permanent, this is where you should be going. I see it a lot in sort of the quick projecting of today's age. Not to be too much of a fuddy-duddy about it, but I mean it's important that your circuit like functions at all. Anywho, got a couple things going on here, so we're gonna get this thing wired up, D1, 2, and 3. We need to start somewhere, and I've already kind of started cobbling this stuff together. Let's get a couple more of the components in our hands, and then I'm going to figure out where things like our high voltage capacitors are going, where the voltmeter plugs in, all that stuff. And we'll probably do it just all up here in the front where all these horizontal pins are. So I need diodes. I had a kit of diodes and I had it out the other day, and then I looked up what the ideal flyback diode is, and it turns out something like a TVS or a Schottky diode is actually an ideal diode for flying back. I guess just because of its openness. So somewhere around here there's a little baggie that's full of diodes. And it may look something like, no, nothing, none of this stuff. I think when I grabbed it, it was towards the bottom of this thing. Let me just make sure it's not out on the desk before I dig too deep. No, I don't see it. Is it under this? Nope. I had one 1.5 amp voltage regulator, right? One of them, and it was in just the right type of package that would fit on this board, and the pinout made sense, and I was like, yeah, cool, I did it. I found the perfect voltage regulator. And then I went to move this circuit board, and the voltage regulator fell on the floor. It bounced off my knee and fell on the floor, and I fear that I will never ever see it again. It is gone. I looked everywhere for it. It was the one singular voltage regulator that would have solved all of my problems and done my homework for me, and it vanished. What a bunch of piss. Yeah, I don't know how militant the Node-RED profanity filter would be, or if it would be particularly useful. I think just some kind of a method to preview the name that goes up on the board, and that maybe in as deep as seeing it come up. I mean, I could always put a Stream Deck button on allowing a name or suddenly canceling it. Maybe I have a burn the subs cancel button on the Node or on the Stream Deck. I could send it. What can I do? If a sub comes in, we can flip the scene to another scene automatically, and then I can have, I think I can send buttons data. I don't know if I can get the Stream Deck to open a folder automatically. If I could, then I could have the burn the subs folder come up, and that could have the big cancel button on it. Cancel the subs. You're all canceled. All of you. It's just sometimes stuff comes up that I just don't want on there. Like, somebody registered my full name as a Twitch name and then gave it a gift sub, and that's creepy. Like, I don't want that up there. Schottky diode, SMD, 40 volts, 60 volts. Let's only go up to 60. Damn it. Need a big abort button. There was a, I mean, I basically just stopped burn the subs functioning, but it's going to be a lot more automated. So yeah, I will need to have something like a, I mean, there's the emergency stop, but then you've got to clean up the database and stuff. So the rectifier, Schottky, but the Schottkys don't go up to 100. We're looking for the flyback diode. SMD switching diode. What does that even mean? But that's only 200 milliamps. I don't know how many amps this thing will be flying back with. An unlaser. It'd be just like a Dremel on a stick. We don't need fast recovery for sure. Rectification would be the only other thing that we'd really do. Because these won't cut it. These go up to 60 volts. Yeah, here's the Nobel Prize for the unlaser. Yeah, erasing it from the board is not, I mean, there just has to be like a little grace period. And in the older the board gets and the more brazen chat gets, I would have time while it was calculating where the name would end up on the board. It would take a while to just like randomly get a good spot. And so I'd have a little bit of time to just go boop, canceled, and then go over to the computer and do all the database stuff. But I need to actually have a button that'll just cancel it immediately. And whatever's already burnt, maybe it should just delete that too. Because I can go over with a piece of sandpaper and just do. I've had to do that before. It burnt like my actual name up onto the board. I'm like, this is stupid. Like, why do I have to justify why I don't like this to chat? It's terrible. Somebody made an account that was my name, and they still have it. I don't know which diode to use. I was going to do a fast recovery, but I guess that's not what we need here. What we need is something more along the lines of, I guess, a rectifying diode would be fine. With the unlaser, no, it would. Well, that depends on what you're doing with the laser, I guess. A laser unlasers itself. I mean, 3 amp, 1000 volt recover or rectifier diode, I guess. That's S3M on this thing. What up, cheesy popcorn? S3M. Here, let's do this. S number 3 and then M. Gotta find it. I guess the best way to find it in this kit is just dump them all. It's actually kind of nice that they actually printed the values on them. That's 16. Yeah. Okay. Huh? Oh, M1. Okay. You guys are how much have you guys defined? Oh, that's from ramen noodles. I gotta clean my nail off. I forget that I'm gonna be under a microscope before I actually stream. I've washed my hands twice since I cooked those noodles. I guess this is just not coming off. Hold on, I'm gonna try to. Whatever. You guys get the cheesy index finger. What am I looking for? I'm looking for, I guess, S3M, I think, is the magic one. Because that's a 3 amp diode. I don't know. Well, actually, S3M, is that going to require more to get it to pop off? Or is it just, I mean, it's 3 amps. I don't think we're going to be running 3 amps. There is going to be a significant amount of flyback occurring because we're hitting a pretty big coil with 100 volts. You know what? I'm going to guess that if it's at the top of the list, then not that one. It's probably going to be one of these big guys. What's this big guy? This is a huge diode. Yep, that's it. So we're going to run one of these puppies on this thing. It's a big diode. Yeah, it's going to be pretty high voltage, and I don't really know to what order. But at that voltage, I mean, we're putting amps and amps through this coil. So, and I really hope the tip 122 didn't break because of, and that was one of the things I was talking about. That's what I meant to, I lost track of my point when I was talking to you guys earlier about solderless breadboards as final designs. We had the solderless breadboard as the final design, and as we were figuring out all the mechanicals of where things were going to be placed and what was connected where, in just working with the circuit, it was enough movement and disturbance to my circuit that an element of it broke and was serious enough to cause an actual electrical hazard. What happened was the TIP 122 was either connected weirdly or the flyback diode was disconnected. Something happened that killed the TIP 122, and I'm hoping this one doesn't die similarly, because that would mean that there's something fundamentally wrong with my switching circuit and not the breadboard itself. But if this one happens to survive, then I'll be vindicated. But in building it on the solderless breadboard meant that this thing was able to die, and then it wasn't able to switch off completely. So there was something like 25 volts sitting on all those caps, and it wasn't dissipating anywhere because I hadn't gotten to the point where I could put a dissipating resistor on the capacitors. So we had to discharge, and I discharged through my screwdriver, and I put a couple little melty spots on it and threw some sparks very excitingly. But the thing is, with that circuit on the solderless breadboard, sometimes you need to jiggle the parts in order to get something to work on the solderless breadboard. And so it really kind of concerns me when I see YouTubers and such building their final circuits on them. It's really just for rapidly testing your idea, not for the actual application. But people get away with it. They get away with it. And I'm sure if it was more hazardous, they would be not throwing caution to the wind and actually building their circuits up. What else do we need? What have I forgotten still? I've got the SM5551 right here in the binder. I've got my 1Ks over there. We've got the 5-volt regulators on the board with 2 capacitors. The TIP 122 is mounted. I don't have the plugs for the 3 elements there. We got the flyback diode, but the coil, voltage meter, and capacitors are just down to soldering the connectors on in a sort of a logical arrangement. So I've got all my parts, so we're ready to start actually working on the board. So first things first, you figure out where everything goes mechanically, as in figure out where your microcontroller is going to sit. I put this all the way up at the edge because we're not using any of these pins. Wow, those are gross. Why are those gross? We're not using any of these pins. We don't need them. If I did need them, I could run them out from there and under the actual microcontroller. D1, 2, and 3 are right here, and those are the ones we're using. And our 5-volt input needs to come over here, which if I had an in-ground out voltage regulator, I could have put that here, but unfortunately, it's not that way. What value of the resistor did you use to discharge? No, there is no resistor on it right now. I don't have a bleed resistor on these. You would put something like, I don't know, like 100K. Don't quote me on that, but it would be hundreds of kilo ohms, because when you turn it off, it'll then bleed out over a long time, and the high resistance resistor will not disturb your circuit in operation. It's not too often that they do that, but when they do, you know they're actually thinking safety. Discharge circuit is called oh bother. What does that mean? What does that mean? Okay, so let's figure out where I'm placing stuff. The voltmeter is just going to be sitting on those high voltage lines. It has thin wires going to it. It is literally just there to tell me what's going on, and it's mostly just visual for you guys. So this one can go further away from everybody else. I can use thin wires to get to it, although this is the low voltage input over here. So if I'm doing the high voltage input, I mean, this is like right there, but I also need the capacitor bank as well as the solenoid. So this is the solenoid. I gave it a unique plug. I spaced the 2 leads out. The TIP 122, the collector goes to the solenoid, the emitter goes to ground, and then this goes to the capacitor bank. So this is low voltage input. We'll take it from over here. And then this would be the collector. So if we do it like this, then that connection to the ground of the coil to the ground of the rest of the circuit, which this lower one is the ground, upper one's the high voltage output. So high voltage output going to this pin, but that has to be isolated by a little transistor. This might have been a bad place for the tip 122. I don't know, the smaller I can make this circuit though, the better it'll be. The high current can flow through it. So if we put a transistor on that high voltage pin, I guess I can have the output of the like the base of the transistor be here. So let's get the 5551 transistor and let's put that down first. I'm getting it. I'm getting it. I gotta get it out of the sleeve. There you go. The first transistor I chose was the right one, which is kind of crazy. It just said 555 on it, and I went, all right, 555. I'll look at this one up first. I did not expect it to be exactly the right thing. Meant for pretty much, well, meant for stuff very similar to this application. All right, there's that. And our output, or sorry, our pin out rather, is very frustrating with these surface mount. Hold on, I gotta put it back into a sleeve. That's kind of hard to get to. There we go. So the symbol for a transistor is this, because fundamentally, a transistor is 3 layers of silicon, right? Like if there's no other whistles and bells, it's literally just 3 layers of silicon, right? And when you bias it, the boundary conditions of the pieces of silicon change. So if I bias that with a voltage, the boundaries change. And if the boundaries change enough on that centerpiece, then current will be allowed to flow through the whole thing, right? So you get a little bit of current that goes down through there, and then current's allowed to flow through the whole thing. That's fundamentally how a transistor works. That's why its symbol is a bar and then 3 leads, 1 for each layer of that stack of silicon. You can think about it like that, and the arrow is going to inform you what the NP and N situation or PN and P situation is of that transistor. So it's a little stack of stuff. It's represented by a little line, and it has 3 leads coming out of it, with the center one being the control pin, right? So when it gets to surface mount, you actually have a package that is a little bar of material with 3 leads coming off of it. 1 is in the center. You'll notice that is not how the transistor is stacked up inside of its own package. Base, emitter, and collector are indeed off. They're off by a little bit. And that's how they always are. And I think that's because traditionally you would put something like a resistor to pull up the transistor or pull down the transistor when it's not in use. Like if the ESP wasn't here, it would be active when there was a signal on it, but then it would be inactive otherwise. So you'd want to have something that would pull the lead down to ground when it's not in use. But yeah, so because of that, I think that's why they made the transistor inside of the little package not what you think it is. Hold on, it's like this, except this is the base, and then the emitter is this one, and then the collector is this one. Oops, maybe an arrow there, or an arrow here. It's annoying. It's very, very annoying. So anyway, given that layout, we need to figure out how to mount this transistor so that I can get into it and put voltage on the line. We need one for checking 3D printed faces. Let's make the SN5551. Let's make it the number 555 so it annoys no bother. Now these are for like Nixie tubes and stuff. It's pretty cool. So okay, I just closed the window and then I immediately forget what the orientation is. Perfect. I'll open it up on the other monitor so you guys don't need to see it, but I do. So coming from the high voltage thing, we're going to go into the collector, which is number 3, which is the one all the way over here. And then it'll be switched to its emitter. And that's this one. Collector and emitter are these two. This is the control. Damn it, it's like, it's all wrong. It's all wrong, all the layout of this thing. Unless I put it over here. Because then I can do collector. Which one's collector? Collector is over here. And then the base, yeah, I think it makes more sense for me to put it right here like this, because then my control pin is over here, and then this is what's getting switched to multiple locations. So I could put the capacitors over here and the coil over here. If I put the capacitors over here, I can connect them to this ground. Even though that ground is still connected to the other ground, I kind of want to isolate it out. This ground just is a ground plane all the way over to our low voltage stuff. It's not really isolated, but is something blowing on the stream yet? Not quite. Not quite. We're a little bit more careful here. We're a little bit more careful here. Typically. Usually it's negligence causing the explosions, not our inability to follow directions or our cruising through a project too quickly and too greedily. We take our time, we think about things, and then it blows up. Yeah, I hope this one doesn't blow up, but it sure is in a spot where it might. All right, so that pulls back a little bit when you solder it like that. I don't like this particular board for doing surface mount stuff. I like the stuff with the square holes, because when you have the square pads, rather, you have the square pads, that creates a nice little boundary, and the surface mount stuff usually sort of sticks around a little better. But I begrudgingly use this stuff because it's easy to find and cheap. All right, so let's move that over a little bit. I just had to make myself comfortable. This is also probably the wrong tip to be using for surface mount, although it does do okay. Oh, gotta not melt that header. I just dove into the plastic of that header. There we go. There's our low voltage pad and our high voltage pad sitting right next to each other. All right, and this one. And then I'll put a 1K right directly up against this. I'm using a 1 kilo ohm resistor. I'm not sure what I should be using. The 1K is just kind of a guess. It's usually a pretty good value to be throwing at stuff like this when you want to isolate away. A kilo ohm is a pretty decent amount. And that'll trace all the way back to our microcontroller. The other 1K should go right up against that, and then I can pull both of them back from there. So maybe just right there. Put that other one down. Was that a 1 or a 10? That's a 1. Okay, good. Good. 1K is a good value to use for diodes, for LEDs rather. When you hit the LED with a 1K, you're not going to the maximum current required to get that diode to run. Usually people will calculate from the data sheet with that maximum value, and it creates these LEDs that just blast your eyes out. When you're doing something on like a solderless breadboard and you want to see that stuff is happening and you put an LED in your circuit, using a 1 kilo ohm resistor is a good idea because it won't totally blast out your eye sockets for observing it without like a lens in front of your face. This is the shadow situation is pretty bad over here. I don't know what's going on. I also don't want to melt that housing. I think I poked it a little bit. I guess it's okay. I'm going to leave that crooked because I don't want to fiddle with it too much. We'll come back here with the smaller wire when the time comes. Right now we're just staking everything out in a location so that we get all our parts down onto the board. I mean, if I held heat there long enough, it might rearrange itself. Now I think the 1K is resisting. Lower value resistors, apparently, the heat translates through them a little bit better, and I can sometimes get it to float on its own surface tension, and it'll scoot itself into position because all that surface tension is pulling evenly on both sides of the board. So high voltage is coming out here, and its ground is here. So if I put the coils down, the capacitors down, I can put the capacitors over here, and then the other thing can be in line. Should I scooch it in or do it just right there? I think that's a good spot. So the positive lead of the capacitors is green. Green going to positive. The negative has the stripe on it. I hope we didn't damage these caps because we had, I guess, negative voltage going through them or something. I think it was backwards, which is not good. So green is positive. So green to positive. And then we also have positive going to the coil, hopefully on the green line. Gotta watch the iron. I think I'm doing damage to that header. I gotta be careful. That's surrounded in plastic, and I'm seeing spots on the end of the iron. That's not good. Usually you can smell that, but I've got a fan on me. And I do that while they're plugged in so that I have a heat sink on it, because otherwise these headers like to blow up from the, not blow up, they like to melt from the heat. So preventing that is just as simple as plugging it in to a thing. All right, so then that leaves the coil. The coil gets connected to the capacitors on positive. So these are the caps. That's the negative lead going into there. The negative lead on this one goes to the collector. So that's which one? Oh, that's in between these two. In between these two, and then the low voltage is that one. So if I really want to, I guess I can hook this up like this. And then we can do just a little loop there. And then this will go straight up. Okay, that's perfect. Yeah, that worked out better than I thought. Now to solder it in backwards and have everything explode. And then I'll put the voltmeter down here, but all I need to do is run 2 jumpers over to the capacitor bank to have that properly do its thing. Although I could move it 1 pin down. Let's 1 pin down, just so there's a little space between my connectors. Just like that. And that way we've just got negative running like that. And then that goes there. And then this one should also go to negative. I don't know how I'm going to do that. I don't really want to have like a lifted element, maybe a jumper over, because I want all that stuff. I want the circuit diagram or whatever, the circuit loop. We're always talking about loops here. The loop needs to be its own thing and not go through anything else, even though they're all sharing a ground. So let's get this solder there. Wait, which one was it? 07 or 08? '07 and 08. I always like look down to find the solder, and then I look back up and I'm like, what was my reference again? Where am I going? What did I say I'd do? Are you my son? So I will reverse these leads just so that they're marked positive and negative properly. Since we're on a DC system, it's just nice to have all your stuff labeled properly. Or wait a second. This gets connected here. This is ground. This is ground. So this just goes to the capacitor bank. Wait a second. Hey, what's up, Copper? Just figuring stuff out. So if this is our positive, then I can go up and down. And then the negative, I'll figure it out when I get there. So I guess, no, but the way that needs to be disconnected from the power supply. And so that is now my positive high voltage. But that's a trickle charge into there. And so this positive needs to be connected to this positive. Over top of the negatives. That's bad. Flip that. I'm not really solving anything. All right, we'll figure this out as we go. The elegance of my solution is not forthcoming. But we also need to get the big ass diode in there too. And it needs to be in the reverse of where we put positive and negative, excuse me. So with the line of the diode going to positive, which would be, yeah, just like this. And then when I put wire in there, that'll actually make a connection. No, I completely disassembled that. I got mad, I disassembled it, and yeah, that's that. I'm gonna drill out this pad so that it doesn't exist. I do not want this pad here. I want a big blank space in between these two leads so that we can put the big diode in there without it shorting out. Use the spoon drill. Spoon drilling is, you take well, it's spoon drilling, and spoon drilling is its own term, and there's other actual mechanical processes. But when I talk about spoon drilling, what I'm doing is I am just moving the knife laterally across a hole in a pretty brutal maneuver for the sharpness of your blade. Since we are using scalpel blades, these things are disposable, and I have many of them, so I do not have any qualms about doing what I just did. Which actually, I think that deleted the pad pretty nicely. The shape of the knife is like perfect today. Yeah, there was no pad there. That was all just exposed, fiberglass. Now see, there's still a pad on the opposite side. I need to do the same thing here. And maybe the drill bit would be a little bit better for doing this. Drill bit's a little flatter. Let me see here. Just get a drill bit. Any drill bit will do. Any old drill bit in a storm. That one's way too big. This one, probably about the size of the pad. Very small drill bit, but. And then I can just controlled twist. And that'll start. No, it didn't do anything. This must be dull. There you go. It just removes the whole thing. There's still a little bit of material in there on the edge. That's a much better way to do it. You just use a drill bit. I hope I got the right one. I think I did. I still need to scrape a little bit off of that. I think because my knife isn't very sharp, I think there's still like a little bit of material in the via. But I mean, it's only 100 volts. It probably shouldn't skip any of this gap. I just want to make sure there's no chance that these two are going to connect while I'm soldering. Because if I solder the diode down, the leads are so big on it that it looks like it might bridge connection between these two. So making sure nobody's going to accidentally solder down and cause a huge hazard. But yeah, the previous version of this board, I don't know, it just didn't hit me right. It felt too sloppy. So we're putting it together again, and this time we're not using optical isolators. We're not putting opto isolators down because it's largely not necessary. And I'm using a transistor to block the high voltage power supply from interacting with the capacitor bank, so that I can isolate that out a little bit and have, you know, we connect it to charge, but then we disconnect it, and that'll keep my high voltage power supply from getting hammered away by the high current tip 122 and all of its weird feedback stuff. That's the idea anyway. Hopefully it'll come to fruition. I don't understand why in my head this seemed to be a lot more organized than it actually is. Because I mean, we're going down through here to ground over here. This is ground. This is positive to the coils, or sorry, positive to the capacitors, and that's over here where that's enabled. I wish I had more holes on this side. I mean, this ground going directly to the power supply is fine. This ground with a big wire needs to go over to here. No, over to here. So this big connection needs to come all the way over to there. I wonder if no, it's fine. Whatever. We're just gonna deal with it the way it is. I'm going to try to make it nice and neat and organized, but time makes fools of us all. Okay, so now I can breathe a little bit easier about that going all the way over to there. There's these huge pads underneath it. So let's get a little solder on that one. We're probably going to have one element of the circuit jumping over the other, which I don't like, but I don't think I have a choice just because of all the stuff that needs to get connected. If I did it in like series with going directly out of the top of the board, maybe I could have made it a little bit more true to what the circuit actually is, like all the layout and everything. But doing these from the side means that we can have these PCBs sitting on top of everyone. No, they're not connected through the board. They are individuals on the top and the bottom. So really, technically, I could run a ground across that, which I probably will do. Yeah, I guess what I can do is run ground from this pin, or just this cluster right here, down, over, and then up here. That's probably our best route. And then we'll drop a big wire straight across there on the top. Yeah, I think Smith Clay got the good solution there. That's good. That's good thinking out. High voltage to that, high voltage to this. That's the one that's going to be harder for us to run. And of course, that has to be connected up there as a flyback, and it's not a permanent connection, so I can't run over this. And that's ground. Actually, this is ground. So this ground connected down to a big bar that goes up there. We're going to have to still have something that like goes up and above. What, hold on a minute. Thinking. Yeah, big ground to there, but then high voltage to high voltage here. It's going to be a mess. I think it's just going to end up being a mess. I've got one layer, but then everything needs to get grounds too. So it's a big mess. This will go here, and this will be the big ground. If I do that down and over, then this and this still need to connect. So that, but then not this. So how do I do that? I need to have something that just jumps over, I guess. Darn it, I was hoping it could be a little bit more organized than that, but I guess not. All right, and then the last one down here is just the voltmeter, which will just get connected across the capacitors over here. So the order might have been off. Might not be the best. I feel like it could be better. Let's just go to those two, 12 and 13. Oops, gotta rearrange that a little better. Okay. This one. Okay, so there's our high voltage monitoring, just simply to look at the stuff going on. So that is the total. Yeah, that's all the parts. 2 more 1Ks though, or no, 1 more 1K going to the shutdown pin. So let's get that one out. 1 more 1K, and then we can do ground. We'll start wiring up the whole circuit board's ground, and then that'll help inform us about what the other stuff is doing. Yeah, I do not know what was wrong with that other one. But I think all of the discombobulation, the sloppiness, and the messiness, and just not really, the circuit not really going down the way I wanted it to was part of the problem. I got a little too confused in all the wiring and stuff. I was hoping that this would be a little bit more simple, but it's just not. It's not. I mean, it's not complicated, but it's just the layout isn't forthcoming as I would like it to be. Probably go back. Yeah, because we're gonna go D1, 2, and 3 over here, so we can just string that this way. I'll just put the 1K right here. The high voltage stuff will be 2 wires that come in right here and go directly, so that'll give us a little bit of space in that direction. Although I could telegraph it on this side, but I think it'll be okay over here. There's a lot of extra space on this board, mostly just because of the size of the modules. So we're not really min-maxing our circuits the way we could. I got room for other stuff in there. I really need it. Getting this fixed to something is a big advantage too, because I won't be in risk of blowing anything up. Okay, so all of our components are down and we are ready to start actually building the circuit. We start with ground. So ground from the power supply to all of the different elements that require ground, and then we can look at the high current ground that's coming through the Darlington. But first, we just do the very simple job of grounding all of this stuff. So this stuff is the power supply. I've got 2 big capacitors just to be nice, just so there aren't, you know, with stuff drawing a lot of current, and I guess somehow this ESP does draw a lot of current. I don't know why, what it could be possibly doing that draws that much current, but it does. So the LM1117 should be pretty suited for that amount of draw. I may have to add something up here as like a heatsink, but the pinout of the LM1117 is so annoying. It's so annoying because it's in ground out, or in out ground, in out ground. Let's just pull it up just so that we have something in front of us that'll tell us what the pinout actually is. So this would be NCP 1117. Pins 1, 2, and 3, and pin 2 is connected to the tab, and it's adjust ground output input. So pin 1, which is the one all the way to the left, is this one all the way out here is ground. And that ground I have to connect to the 2 capacitors that are going to be on the input and the output. Yeah. So this one, I'm going to have to go out and around and connect to here and here. So let's do that real quick. That's cool. All right. For grounds, I use wire wrap wire. It's 30 gauge. Yeah, 30 gauge. This is just exposed solid core wire. The signal lines we will do in wire wrap wire as well, but those are actually going to be shielded and they have color coordination to them because back in the day, you do wire wrap circuits and yeah, you'd be wrapping the solid core around a little post. And that gives you a sort of like a cold weld on the metal. But in our case, we're going to be soldering a circuit to the perforated prototyping board, the solderful breadboard, and using this stuff as basically just a way to lay down traces. So I use a tool to do my corners nice and neat, although that one partially is soldered, so it's not going to help me. Damn it! All right, so I can sneak that over just a little bit. That excess of solder made it tough to maneuver that thing into place. Oh, now it's going to be too long for the... Already, my very first connection is ass. All right, hold on. Redoing it. Redoing it, resoldering it. This would be ground somehow all the way over here. And ground is here on the thing. So I'm going to go, that's going to block everything. I already hate this. It's already left a bad taste in my mouth. These will have to skip over stuff, I guess, on the output, at least. It's like that. And then I'll solder the next one in line so it holds in place. Because the whole reel is falling. I should just take a cut and work with. Wait, I didn't mean to do that. Oh no! Stupid. What's wrong with me today? I don't know. All right, I'm just going to take a cut so I don't have the whole spool sitting on this thing. All right, I'll bend that while it's under heat, I guess. Oh, wait, it didn't solder. Okay, well, that's the one small advantage from my mistake. I don't like this at all. This sucks. This is really bad because it like this loops around and blocks everything. It just seems like a bad arrangement. But that's how the regulator is. It's what they did this, not me. With the ground in the middle, it would have been a lot more easy for me to lay out. It's going all the way over to there. Jeez. Nope. There. It's hard to do with the tweezers. The tweezers aren't as good at bending as the little pin gauge tool that I've got. And I can drop the hammer. If I could find it. There it is. Ah, yeah, let's just get the X-Acto knife to sit around where your mouse wire, your mouse cable is, your mouse cord, sitting right with this knife just hanging out around it. What the heck? Oh, I see. That's soldered. All right, and then ground over here. Second pin in. Second pin in. All the grounds are going to be exposed, and then all of the other signals are going to be on color-coded wires. Doot and doot. Give that a little doot. Put that on. I make sure that's on top. Would have been better if I had gotten this a little bit more towards the center. There we go. Yeah, 30 gauge wire wrap wire. Very useful stuff for making a circuit like this, where things are sort of temporarily permanent. Permanently temporary. Come on. Is that not? It's because the knife is like tontoed because it broke the tip off. Can't tell where it is. Probably should get another light source just so I can have one from the left. The light source on the right is the one that I move around in order to get good visuals for everything. But because of where it is, it ends up casting an enormous shadow on everybody. We tried to put current protection on this, and it turned out it just tripped immediately. And that could have been because of the bad circuit from last time. Maybe I could work a protection element into this, put it like around here. But for now, I'm just going to wire this flat. Oh, right here. My blocking grounds. So then output, I will take to throw an electric match. What? I can't pick it up off of the, use the tweezers to pick it up. There we go. This will just go over and up to the output line without making connection. These are just big capacitors. That's all. Their whole purpose is just for little transients. I can't even see anything. Use with a bang. I don't want the bang. It's out of the way. Where are we working? Ah. See, I can't see what I'm doing, and I don't have any light. Jeez. I don't know why. Some days this stuff is... I think it's this vise is a little far off of the bench. It's the miniature one that's really much more maneuverable under the cameras, and it keeps... I think it's at a height where I don't see my shadow all the time. We may try to move this to the small circuit, to the small vise. That might be a better idea. Solder always walks all the way to the end. Might be better for me to switch tips on the iron too. A smaller tip. So now this capacitor here is connected to the output, and now this capacitor gets connected to the input and this output. Nothing in between. There could have been something in between, but we can't have nice things. Should I do the full U, or should I just go straight over and do a... Let's just do the junction. The U would have been a little bit more elegant and not involve a tiny little scrap of wire sitting right there. Oh well. Oh well, I say. All right. Everybody's critic. Whoa, heat? Oh, iron turned off. There's a control that I don't think I ever want to give chat. The ability to turn on and teleheat and keep my iron from being hot. Yeah, I don't like this. We're going to do the U. I'm going to go full U. This is too annoying to work with. Get away. Okay. And if I do it right, I can use up this whole piece right here. I tried doing this whole perf board work before, ended up having to lay it down in KiCad. Whenever I start that, I just make a PCB. Because the hardest part about doing stuff in CAD is getting the parts in. That's the hardest part. Like laying out the circuit, figuring out where things should go, and figuring out how they should be wired. That's the easy part. And I made a perforated, you know, they have CAD models of perforated prototyping boards. So I could pull all of that in, pull the perforated prototyping board into CAD, and figure out what the layout should be. But by the time I do that, I might as well have just drawn traces and physically, you know, get a PCB made for $5. People used to do that. I mean, they used to figure out what the prototyping board should look like in a CAD program, because yeah, you've got all of the you've got the ability to Control Z whatever you're doing. But yeah, again, the proliferation, the ease of availability of $5 PCBs that are entire professional PCBs makes it so that if you're doing that, you might as well just make a PCB. Every time I do that, I spend days messing with the trace routing. See, I normally don't. Trace routing is like the real, you know, brain tickler for me. It's where my ADHD brain starts fizzing, and everything becomes clear to me, because all those decisions that you make with figuring out what the parts are already made, and then as you start putting down those traces, your decision window starts narrowing, and you see the solutions ahead of you as the only solution. It's a fun thing for me to do. Of course, then I end up moving a trace, and I have to move 65 different traces after that. That reminds me, I need to get back to designing Julian's thing. What's that? Big thud noise upstairs. Sounded like something dropping. Set iron temp to 340C. That would be terrible and dangerous. Having it activate in teleheat would be pretty funny, though. It's going to be like, why isn't this soldering? And they're like, oh, you little bastards. Oh my God. All the whistles and the bells and the little things buzzing and clipping and making noise and doing all kinds of crap. People are going in and out of the house. I don't have any control over it. So 5 volts is here and here. It's a little weird. I don't know how I'm going to be able to get that. I guess I'm just going to have to use a wire and just go up and over. This is kind of annoying. But we've got ground routed to everybody over here. We have our power routed too. So if I plug this in, the LM1117 is going to create 5 volts and then nothing will happen, which is totally and completely what should be happening right now. It's fine. I don't really have room for a wire to kind of sneak down there, do I? I guess I can come from up here. I do kind of want to keep this free because we have 3 signals coming out that way. So I could do 5 volts to here and then skip it over to the tab that way. I guess that's my one route. That's my only way of doing it. And then 12 volts has to go all the way to the high voltage regulator. And that would be from here to the opposite side of the circuit board. That one's going to be kind of annoying. Motion detector for 1 second. Stop. You just get a little bit of relief from that thing always telling me that something's happening. All right, I'm going to get rid of the solder on that one. We'll skip under and solder in. Oh, whoops. I must have clicked. 5 volts over here. And then this one's clear it up. Yep. And then I guess I'll drop down from above so that we can keep all the wiring on one side of the board. Maybe all of my vertical jumps can be on the other side of the board. Although this one's going to be very horizontal, so I don't know if I can quite organize it that way. Hopefully this one comes out a little bit more organized than its predecessor. There. Whatever I see, you guys are seeing. So if I'm using the microscope, you'll see it through the microscope. If I'm doing this with Mark 1 eyeballs, you guys get a slightly better perspective than I have with Mark 1 eyeballs. And I guess I could just, no, I'll come down like this maybe. Because I don't have room between those two, and I don't want this to interfere. It is going to go over this, though. But I guess I can kind of avoid that by going wide. You know, technically, no, but ground is right there. If I were to do ground, no, I can't. If I were to do ground a little bit differently, I could maybe run across and down to where the 5 volts is, but maybe it's just better like this. See, what I could have done is, where's my mouse? What I could have done is move ground in and down, so that's coming down on the same row of holes here, and then I would have freed up this row. But since ground is here, I don't really have any choice. It could have been something that I did, but unfortunately, and I didn't want to move this in any further, although if I did move this one row over, I guess it would still be fine, since we're not exactly putting an enclosure around this thing yet. That's a bunch of decisions that I can't unmake. I'm not about to move this whole thing over by one hole. That's going to take me hours to do. So we'll leave it the way it is. And this will just go straight down here and plug in under the board, because on the top of the board I may need to do heatsink. Over one, and then Bob's your uncle. And that's our 5 volt. That's the only thing that really gets 5 volts too, is the Arduino. Shame the Arduino can't run at 12. Its little voltage regulator doesn't allow that. But we have LM1117s that can take 12. What can the ESP8266 can't take 12 volts in? No, that's absurd. I think it's just 5 volts for USB power. Would be nice if it could do that, though. Although I guess I could run a 3 volt LM1117 and then I could put 3v3 into 3v3. But that would require me to put power in all the way over here. Still doable, though. No, we're just going to live with that one. That's just one of the decisions that we're just going to have to take to the grave. It can never be undone. A little bit of wire sticking out of that. That'll be fine. All right, 5 volts is hooked up. Power supply is hooked up. We don't have grounds yet. So ground needs to come out and to every other location that ground's going to go to. So this ground is going all the way out to, which pin? The top one. No, wait. Over here. In, shut down, ground. So ground has to come all the way down, and this one is already connected to a resistor. So we have over here to work with to get V in and ground all the way down to... All right, so I'm going to have to do this with wires. We're going to have to put wires all the way up to the power supply. So that means that that ground... Yeah, because then the wires will be the source of ground for the rest of the circuit, and they'll be small enough that they'll explode if anything weird happens. But then we need probably a... We don't need a big 12-volt wire to go up to this thing. The biggest thing that's eating current is going to be our Arduino. That's the thing that's really going to be able to do it. I'm working on a project and I'm juggling voltages too. Made a relay switch box with the plugs separated. It has 12 volts for the relays, and then my ESP gets 5 volts to make 3.3. I think I want to skip the USB and just regulate 12 to 5. Yeah, I mean, skipping USB, not relying on USB power is a good thing to do because sometimes, you know, the USB bus isn't really up to it. And if anything feeds back to that USB, it can be a problem. You know, you don't want to blow up all of your USB capability through the USB socket. So it's always nice to supply your own 5 volts for stuff. Be kind to your electronics. Which one's ground? Ground was the top pin. I need it all the way up here. Just like that. It's going to get a small connection. This is not, all the high current stuff is being done up here, but we are grouping up all that high voltage with capacitors. So we really shouldn't see a heavy current draw from this. So I don't need to use big wires. But I would like it to make sense. Well, this is not really going to make sense. It's going to have a weird route incoming. Weird ground path. Who dis? We can just take that right there. I probably shouldn't use my nails to strip these, but that's what I end up doing. It's always on me. I'm never not without my nails, you know? Might even make a board with a 7812, 7805, and an 1117 3v3. Cascaded regulators isn't good, but efficiency isn't a factor. Yeah, I mean, simplicity is always nice, but... You know, the 1117 comes in all those different flavors, too. You'd have a cascade of 1117s. All right, so that's ground to the high voltage supplier. Now we need 12 volts to the high voltage thing. I'm going to use this wire because I think the 30 gauge solid core is going to be able to tank the amount of energy that this supply is going to need. It's 80 milliamps at 100 volts. I don't know what that translates to. Does this give me like a wattage? Up to 230. 12 to 24 volts. I don't really know. So I'm just going to use this wire and hope for the best. I see. Better because they're low dropout. This would be the 12 volt supply. I guess I can go the row behind this one. Although doing them right next to each other would have been fine, but... V in, ground, and shut down. The yellow wire is a slightly different wire than the other ones. It's like a little bit more clear and plasticky, and so it melts a little differently. I really like it. 1.2 volt minimum overhead where 78 needs 4. The 7805 only needs 4. I see. Sounds annoying. It sounds annoying. That didn't solder. This wire is notorious. The wire wrap wire can be very annoying to deal with. I'm actually going to take a cut of that. Oop. You strip it. Oh, this stuff is so annoying. We should be able to get this thing together pretty quickly. I mean, we're almost there, practically, at this point. I've got like 90% of the connections done. I'm just cutting it at this point. What is... Okay, maybe this one. There are special strippers for wire wrap wires. If you get too annoyed with this stuff. There, that actually worked. This goes to 0.2, which is 30 gauge, which is exactly what I need. Neat. Too bad I can't maneuver those in to the little areas of the circuit more often. So this one is going to the input, so I can actually take it all the way back to there. Well, that's not really that convenient of a location. Yeah, start here and then work my way either across. I guess I can go back with this. Yeah, that'll have to be the way. The way of it is I'll trace over there with this, and then I can do this connection directly here. Can I actually get it to skip over the stuff? No. That would have been nice. Yeah, there's a big capacitor in the way. That's the problem. Okay, let's see. What can I do? See, I'd rather have this. I guess maybe I can just run it all the way. Yeah, we'll do that. I'll run it alongside the other ground, but it won't jump layers. And then it'll just be stuffed on the top of the board and out of my way. Can't see what I'm doing. You guys can kind of see what I'm doing better than I can. Oh, what I'm doing is not soldering this is what's going on. Come on, man. Solder in. Do us a favor. This is really annoying. Okay, hold on. I can fix this. I can fix this. I know what I'm doing. I know what I'm doing. There, wait. No, so wrong. I'll come back and fix that. Yeah, that's terrible. Terrible. So I'm going to go back here and then over and then down. I think right here would be a good spot. Well, maybe back a little further. Right there. I mean, I guess just to keep it safe, what I could do is jump. This, if I need to rework power, it's really going to be a problem. But I can skip under the header like that, and that'll just keep it from snagging on stuff. That's really the main consideration here that I'm doing right now. Is like, I need this to be sort of the organization of the dangerous elements, and so I don't want it to catch on stuff and explode or any of a number of things that could happen, and then this thing explodes is what I'm trying to avoid. Usually when I change layers, when I change directions, I would change layers. It's just there's some elements of this that are a little weird. That's pretty good. I mean, I guess that's okay. I can't stay mad at that. I can fix this. Yeah, that's the typical attitude. All right, leave a little bit. Cut that close. Instead of using my nails, use the actual wire stripper. That actually works really well. All right. How's everybody's Fridays shaping up? I'm doing okay. Can't seem to control my light anymore. Story of my life. Stuff out of the way. I'm going to stretch my legs a little bit. Move my butt. Make sure that I've got good positioning here. All right. And then solder. Okay. Where is the micro? Oh, there we go. All right. So this little guy right here is my 12-volt output. Not very well organized. I don't know what's wrong with me with these circuits. Just the layout just seems so, I don't know, counter to itself. I think maybe if I put the microcontroller on the opposite side, it would have been a little bit easier. Or if my voltage regulator had sort of a normal pins on it. It's just the ground should have been probably opposite of this. Just go right down here. One of those like ray gun birds out there. Pew, 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 pew. Birds making pew pew ray gun noises. All right, I guess I left a little extra on there to make the jump over. Probably shouldn't have done that. I could go directly over and then just like straight down. It'll be this tiny little jump, but I'm leaving a little bit of excess there. I don't know if it'll bite me in the ass later. Like I said, this can catch on stuff, like when I'm maneuvering the board around. And also this one's a little bit close to the where I'm going to put the standoffs. So I need to make sure that a screw doesn't crush that when I actually put screws through this thing and have it on standoff so that it doesn't, you know, hit up against something metal and explode. Again, explosion mitigation is a pretty big motivator around this sort of thing. Yeah, I guess what I could have done is kept that ground wire up and just put it straight down there. Instead, I've got this sort of big crossway thing going on. I guess it's okay. All right, so D1, explosion equals not ideal, and then the ideal light made a little yellow explosion over there. It catches ideal as well as idea, because I built it and it's super good. What is the cable caught on everything? Thanks. Jeez, there's all kinds of stuff sitting on it. I need to clean up around here. I really do. I need to clean up. Things are a little bit crazy. But before we do that, we've got to do the rest of the low voltage stuff. So I'm going to need 3 unique wire colors from over here. White wire, blue wire, well, purple wire. I guess we could do purple and blue. Although they're so close to each other, I always confuse them at a glance. Blue is significantly different enough. Okay, 3 wire colors for our 3 switching elements. An explosion to launch each emote. That would be fairly expensive in the long run. I know some of those satellite systems have this type of gel that apparently you can get multiple different explosions out of. So they'll excite the gel or piezo element or something, and it'll make a little poof out of it, and you get like a certain number until it's rendered ineffective. So number 1, the larch. Let's do purple over to there. So that'll be D3. D3. What direction are these in? This. So TXRX 1, 2, 3. TXRX 1, 2, 3. This one's going here. I'm going to leave a little bit of a runoff on these so that I know what, well, actually, let's Yeah, so you know what wire color it is. You can see a little bit of the wire. Ah! Father, are you wide awake? Why do you ask? What's up, Rickard? Wait. Wide awake has idea in it. Jeez. That's an interesting one. That's very clever. Idea awake. All right, blue wire going all the way up to this resistor. I guess we could do it this way. I can come in from this front, and then this is again why your software leaves it open what pins are assigned to what, because you can put it together so that it makes the most sense, and then in your software you can change the value. I was just looking at a list containing idea for the exact same purpose. This is a pretty good one because it caught me off guard, and I'm like, why are you at? What do you care if I'm awake or not? I'm actually going to move this away a little bit because I expect this thing to get hot. So I kind of want to move this wire away from the big FET, from the big tip 122. So we're going to totally redo that, and I'm going to move it one row. Yeah, I guess one row. Part of this is when we get this done, we're going to do like a stress test on it to see if that tip 122 broke because of some idiocy on my part, if some part of the circuit is a little too harsh to it, and that causes it to naturally break. You were at wide awake when well, maybe there's other ones, but that so far has been the most clever. Yeah, I'll just do it like that. There we go. That gives me just a little bit of space from the tip 122, which is managing quite a few amps of stuff. So just like that, and then I'll just clip that with just a little bit, and we don't want to. Last thing I want to do is to bypass one of these 1Ks. These are our only line of defense. There's a lot of medical terms. Oh no, medical terms are all over the place. I'm wondering when they're finally going to run out. When they're finally going to run out of names for prescription drugs. It already seems like they just let the cat go across the keyboard when they're naming these things. And what was the one that we found? It was literally like faux shizzle my nizzle kind of stuff. It was a sheezy. Oh, what was that one? It was Shaz something or other. The medical name was so not serious. It just sounded like an early 2000s rap line. It was awful. That wasn't Shingrix. It was something else. We pulled up the webpage. It's hilarious. Sidearm and Hideaway. It didn't do anything for both of those. Weird. Sometimes it just misses. Sky Rizzy. That's right. Sky Rizzy is the Rizm no Kisler. Hold on, where is it? Let's see. Here we go. Risen Kism Bariza. Risen Kism Mariza. What the fuck? This is not a serious drug. It's the Risen Kism Mariza. What the fuck? Yeah, riz up your doctor about Risen Kism Mariza. I feel like I'm taking crazy pills. We gotta fix this 12-volt input over here. If you feel like you're taking crazy pills, talk to your doctor about Kism, my brother. Is such a non-serious name. And they decided to call it Sky Rizzy, which is just weird. This is all wrong. Everything I'm doing just keeps getting more and more annoyingly wrong. Just solder down, you stupid wire. Christ's sake. Just. Oh my God, I'm going to have a conniption fit. Good. Oh, not good enough. It's not connecting now. It flew up in the air once I released the soldering iron from it because there was so much latent heat. There. How about that? Yeah, I can't fight that. It is, yeah. Early 2000s and medical names for some reason have run out of ways to communicate. So I guess they put in their random medication name generator. Yeah, these connections aren't the best that I've ever done. Okay, we still need to do the whole high voltage section, but we're getting there. I'm doing the remainders of the low voltage stuff. So we need these two, which are the two low voltage switching signals that are going to allow us, first of all, to put 100 volts onto the capacitors, as well as switch the whole damn thing. So yeah, at least with Sky Rizzy, the original medication name is baffling and unserious, but that is what they call it. Risen Kism Bariza is a thing. It's a substance, and they have a naming convention for that substance. as ridiculous as it sounds, and is. So the next one, I guess, is going to be the tip 122. I could come from the back like with this one, or I could probably just grab it up here. So we'll just grab it up here, and I'm going to leave this row of holes free. So we're going to go back here, and we're going to go to the next one over, which is this one. So right here with the negative of this capacitor. And then I would like it to have a little bit of room when it goes up here. So I'm not going to go directly next to the tip 122. I'll probably jump around the corner and then maybe, I don't know. If I'm going to keep the wires up on top, I guess this one's just going to have to take a weird route. That's just how it's going to be. So having the different colored wires is going to help me when it comes to reprogramming this thing, and it's going to keep things hopefully at a glance repairable. That's right, they've got AI now, so they can generate the medication names with AI. Do they? I mean, they've got to have some kind of a filter so that they don't accidentally Scunthorpe their medication names too. I wonder what kinds of explicit medication names they've accidentally created using whatever the hell systems they use. It can't be a human. There's no way. There's no way that it could be a human doing those medication names. If it is, I feel bad for that human, but still. So we want to leave a row of holes next to this thing. I could go one row over and go up to here. I feel like I should go over here, but then I'm getting in the way of the standoff. There's a big old standoff that this thing sits on. Actually, this might have to move because of that standoff. Let's take a look. I haven't tried this yet. Plug in the thing. See where they lie. Yep, I can't use that. Can't use it. It's in direct connection with a standoff, which is grounded. That one's got to move. What? To help you write what? So I would love to move this to a place where I guess I could go up here, but this is 100 volts, this is 100 volts. So if I go across this, just directly downwards, I guess that gets the wire out of the way. But it really doesn't get me any further from the 100 volts. All right, it's right there. What's up, Botham? So this is a little circuitous. It's going kind of all over the place. I don't know. I was hoping it would be a little bit easier. Let's just get the solder out of here. I guess I'm just going directly over there. So we'll go to the tip 122, and then our charge circuit will be the one after that. And we just hope that that driver doesn't explode anything around it. Yeah, I guess I've just got to live with a little bit of wiring sloppiness here and there. I got to get over myself. We're taking our time because this is a 100 volt circuit, and I'm not effing around with stuff like that. I'm not messing around with stuff like that. I want everything to work the first time, and I don't want to have to troubleshoot a 100 volt circuit. I want to know exactly what went wrong when. So when I hear a big loud snap, I can look directly at the transistor that we're putting in and know that it's blown up. Due to the incredible amount of high voltage feedback that a 100 volt flyback circuit receives. That's not well soldered at all. No sure, no sure. We will be coming back to this area in order to do all of the big high voltage stuff. For now, I'm just running the low voltage stuff out to where it goes. I'm doing this in segments, and I'm making sure to keep my head about me as I do this. Unlike the way we did this last time, which is where I sort of just cursed my way from one end of the board to the other while hooking everything up. This one's coming from over here, and it'll probably have to drop down in this hole there. So I'll put this into the next hole row here. We'll just go from there. That goes there. This gets a little strip on the end. That took a long time. How much uncompressed audio is too much? Do I have Dirt Rally 2? I don't know. I think I might. Were we playing original Dirt Rally and not 2? I don't remember. That was a long time ago. Back when I did game streams. Remember that? This technique looks pretty sloppy, even when you do everything right. Just how it is. Okay, and then this is loosely following its buddy. And then it follows its buddy all the way to, and it could probably have gone here, but this is the 100 volt source. So in moving it away, I've moved it all the way out here. And I guess I just want to go wide. And I don't want to use these. Unfortunately, I can't use any of these 6 holes because of the standoffs that I'm using. If I soldered to any of those, that would mean that our signal is going to a ground, which generally is frowned upon by my peers. Generally frowned upon. And I don't want my loose wire to get close to the 100 volts, although it does have to over there. So I guess that's just the way it is. And that's annoying. A little bit of space. Simulated a rotary engine and the noise? Huh. Is that really where all the audio is going, is towards engine noise? Real recordings of motors. I feel like I'm neglecting my Twitch chat here because I'm paying more attention to the soldering today. But after last stream, I just my eye twitched, and I decided that I needed to do this properly. And so I collected 90% of the parts that it would take to put this thing together and figured out what the layout was going to be. I ran out of my small circuit boards, the ones that are a little bigger than this one. So I had to make sure that everything would fit in the slightly smaller layout. But it looks like everything should be fine. And whatever the hell happened to the other one to make it not, fully charged to 120 volts or to 100 volts, I don't know. I don't know what caused it. All right, so we got our 3 thingies. Our low voltage thingies are all set up. Triggers. Got my wires running through here, doing their thing. Staying out of the way of the tip 122, so we don't have any blowouts. Double check my wiring of the voltage regulator, because it would be a funny joke if I did it backwards at this point. No, pin 1 is adjust ground, pin 3 is input. Yeah, okay. Pin 3 over on the right, that one is input. I don't know why they changed the layout on these stupid things, but I guess some circuits make more sense to be in the other orientation. But so in, ground, or sorry, in, out, ground. And the output's also on the tab. And the tab can also get another piece of metal if I need to dissipate heat. So D1, 2, 3, so it's 5 volts ground, TX, RX, D1, D2, and D3 is over here, and it goes straight up there. Although I guess I could have had this do the thing that all the other ones do, and it would have made a little bit more sense, and I wouldn't have had to remove the microcontroller in order to see where that wire goes. Huh. Oh well. 12 volts and ground are going there. The shutdown pin, of course, goes to a 1K, and that's D3. None of the other pins of the ESP are being used. It's really just, the 7 of them on this side. That is fully hooked up. We've got the voltage regulator ready to go. The thing that is not hooked up now is high voltage. So we have high volt and ground coming from this side. Now our ground from the power supply goes in here, and the grounds on this board, they're all connected together. There's no isolating of ground. This ground, you can see it goes out to the ground plane, and the ground plane goes all the way over to this ground over here. So these two are just like a bar of metal. They're just connected together. All right, I'm gonna stand up and get a glass of seltzer so that I don't get blood clots in my legs, and so my butt stops hurting for just a second here after sitting down and doing all that soldering. We're doing the high voltage stuff next, and for that I'm going to want to use this stuff, although I might use a shrouded wire. I might use something with a shroud on it. Oh, my butt. I got portable butt. Portable butt. It's like a butt that you can take with you. You dare. Don't you dare overfizz. Okay. Weren't they considering, wasn't Battlefield or Call of Duty, maybe it was, Call of Duty was considering just selling you a hard drive with the game on it? It's like we reinvented the cartridge. It's just a solid state drive. All right. Power, 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 ground, ground, ground. I got a lot of that stuff going around. I'm going to make sure that everybody gets their proper voltage and that they have enough stuff to dissipate said voltage. Now, there's a couple low current things that I need to do first, which are the resistors. The other sides of the resistors need to connect to the stuff that they're near. If I don't do this, then we're going to get all the way to the point of testing, and I'm going to go, why did nothing happen? Yeah. So, where are we? We're over here. Hey! I like the idea kids are going to be blowing on their M2 drives. Call of Duty with the update, 190 gigabytes. A nice 256 gigabyte SSD drive would be nice. That is insane. Why do people play those games? Why? Is it fun? I just see people get frustrated with those games. But I'm a weirdo. I play weirdo games. That's why I like watching Rabaz and all them. I don't like these like big popular game that makes you feel dumb. Hey, did you guys play big popular game? Portable big popular game. There's not enough quotes around fun. You need more quotation marks. Used to love Call of Duty, but it's been a while since I played any new release. I have a friend who played a lot of those games, but I never could really get into them. It didn't really, I don't know, the feel of it was off. Personally, I mean, I love a one-player game that I can cheat at. Because I enjoy dissecting how games go together. I think it's normal for AAA games to be 100 plus gigabytes now because they don't compress audio, right? I think that's the reason. They just refuse to compress any audio. Where's the 3-pin header? This is the 2-pin high voltage one, right? And so that's my MOSFET, which I don't think is connected to high volt. No, it is. Oh no, it's right next to it. So yeah, we need to put one right here. 8K textures will do that. Yeah, you know what? I haven't experienced lately. I've not, you know, I haven't been around a friend's house to see what it's like nowadays. I'm sure those big textures and all the 100 gigabytes of game that you're installing look pretty good on a modern system with good, you know, good resolution and everything. Or, you know, like on your home theater system, I'm sure it looks great. But I like my garbage little games, either very old games or new games that look like old games. I've not been in that world of, I just spent $90 on a new game. And there's a market inside the game that's going to nickel and dime me. I love gaming. Gamer's asking for more detail. Audio and a bunch of different resolution assets. I see. Being good at an FPS. Yeah, I don't know. I've never known that. In college, we used to play Counter-Strike a lot. I don't mean Source, I mean Counter-Strike. And so they would not be having a good day until they were accused of cheating, which they weren't. I could see that they weren't. They were just extraordinarily good at first-person shooters. You guys, back in the day, you saw me play with my buddy, not college buddy, he's a childhood friend, but I've known him a long time. He's really good at FPSs, and so I end up just kind of tootling from room to room trying to entertain myself because everything is dead by his hands by the time I even realize I'm playing a game. So there's just no chance. I'm just cooked from the start. So I just kind of hobble around and have a silly time while he murders everything in sight. That's how it always goes. I feel like there's a connection I'm not making. It's this one right here. Human spin bot. Like those guys were not satisfied until they were accused of cheating at the games that they were playing. And people would get real mad to the point where they just made their own server, and so they just kick people for fun. But like, I don't know how you get that good at the first person shooters, man. I just don't know. They were my age. Somehow they were just super good at it. And I guess there are some techniques that I was never taught. Nobody ever taught Bother any of these first person shooter techniques. So I run around like a silly little guy. Yeah, that one should have soldered over here ideally, but it's soldered to the one on the other side. But then this is going to get connected for the high current stuff. I'll have to do a wire that goes up and just knocks over to the side like that. What are you guys saying? Skill issues in engines. There's something to the old Counter-Strike. It has to do with like refining your shot by strafing and stuff. I just don't know how to do any of that stuff. New $3,000 LEDs are finally catching up to CRTs. Huh. The wobbly 7, interesting. So that's how people would get good, is by knowing that sort of, because I know that pattern. I played a lot of that game. I was never good at it. And then many years later, Andrew, the buddy of mine, is like, by the way, like, you just get the crosshairs close and then strafe the rest of the way. And I'm like, I'm too old to learn muscle memory. I don't know why nobody told me this. Nobody told me this. Counter-Strike, you need to stay super still to make a clean shot. It used to be run and gun. I have a hard time in Counter-Strike. Yeah. I guess I was probably okay at it, but I was never good. Never good. There's like 2 switched over to a noisier pattern. That's the one with the, do they have that yet? I thought Valve was working on it, and it's going to have like the smoke patterns and everything. Maybe we don't use this wire. I think this wire is maybe dangerous. It's too big. Too big, too old, too crappy, too crusty. Let's use breadboarding wire. That stuff was able to take the current last time, and I've got a huge variety of it sitting over here. Oh, you guys can't see because I went to the wrong scene. Bonk. There we go. We got this stuff. Wire. It's not wire wrapping. It's breadboarding wire. And these are all the offcuts. So I'll just take one that's obscenely large, this extremely long yellow wire, and I'll just use that. Is fine. All you see is a solid color. Never be as good again at FPS with my Microsoft mouse and CS 1.6. Hey, as somebody who is somewhat addicted to the Microsoft mouse, I know the struggle. Man, the Microsoft mouse is so good. Back when nobody even considered mechanical keyboards and shit like that. Insulated steel. No. Now we're just going to use normal wire. Normal wire. And apply it right across here. So that will go to this, and then I'll put a little bend in the end. Just a little bend. Got to make sure that I don't steamroll any of my stuff here that I'm using. You can break stuff by running over it with your big vise. A hole in the thumb spot. SteelSeries had this problem with their mice where the rubbly bits were no longer rubbly because you rub through them. And I don't think they did anything to correct that. SteelSeries and me, they make that wonderful Microsoft mouse shape that I love. I don't know why nobody else loves it as much as I do, but nobody loves you the way I do. Like I said, Stockholm syndrome. But anyway, nobody really like makes the Microsoft mouse kind of shape. None of my friends really like it. And SteelSeries, the mice keep breaking for like weird, stupid reasons on me. And I still go back and get another SteelSeries mouse. I don't know what my problem is. Like, don't get SteelSeries. Just don't. Don't do it. There's nothing to be gained. Their mice just randomly die. And I keep buying them. Why? This is my old Logitech wireless. It lasted for 6 months on a battery. Yeah, those have been getting better, haven't they? I've never gone wireless. I really don't like having to remember to recharge things. But apparently, like, you, even with them now, you don't need to do that. You don't need to, like, worry. They just kind of, like, work. It's like they have a nuclear battery in them. Yeah, I always keep the wires on the keyboard and mouse. It's just how I operate. But they've gotten to the point where you can just, like, ignore them. And apparently it does okay. Can you actually solder instead of just having solder on you? Thank you very much. Oh, actually, that middle one needs. The shadows are really getting on my nerves. It's this vise is taller than the other one. The other one is like perfectly calibrated to work within my system of lights and cameras and stuff. This one is casting an enormous shadow on everything. Is that just straight up? Ooh, all of my patience is just evaporated. How did that just straight up break? Not even a little remorse. This is the high current section, so I'm actually good with it being this full of solder. Well, really, I could have just put it on the soldering braid and done it just the same. Logitech scroll wheel still under the patent until 2028. Click to switch between infinite and clicky. I had a non-Logitech. Well, wait a minute. Was that Logitech? It might have been. It must have been. That must have been Logitech then. I got my mother a mouse that did that clicky scroll and infinite scroll thing. I mean, I don't need that either. I like clicky scroll all the time. So this is switching ground. So this pin here needs to go to high current ground, which is shared with the capacitors. That's over here. So that ground is probably going to need a big element to it, and I got to stay away from these 6. This pin goes there. That is a very annoying jump. E305 lasts many, many months on a battery. That's on one AA nickel metal hydride rechargeable. Jeez, it's crazy. Yeah, they've gotten good at making those efficient, huh? So ground is here. Ground is here. I need to make these connect. And then maybe I can just run a wire up this end to there. Let's see here. Okay, so I need to tin this one ahead of time, and then it needs to go basically just drop in right here. Which, let's see, does that connect? Or why is there solder right there? What is that connection? Because it should only go straight up to that. Straight up to that. Oh, that one goes all the way to this pin. That's right. Okay. So that one is yeah, that one's where I drop ground. Okay, so that is on the non-band section of the flyback diode. Flyback diode being in there the opposite way, A plus C minus. The cathode is actually going to the positive on this because it is supposed to get fly back, not fly forward. Which way are we setting the clocks? Just take that tinning. There you go. And then I need to plug something into this so it doesn't melt. It's going to be awkward when I cut that. Maybe I can, well, if I bend it a little bit, then it's going to have that bend in there, and it'll be annoying. You can just get it started and then cut it to length. Or just cut it and drop it in. Cut it and drop it in. Yeah, infinite scroll in games would be pretty bad, huh? Because then it's like your your weapons wheel is a little bit more amorphous. A little bit more amogus. Whoa, why are they both moving? There's solder on the other side, right? It didn't drop solder down there. Let me check. The body of the diode, I guess, is heating up enough to solder. Infinite scroll and Half-Life for weapons. You're going through the whole catalog. All right, let that cool off a little bit. And now maybe I can sneak this thing up in there. These should be big wires. These need to be big because they're going to channel a lot of energy. Oh, great. Are we soldering to the other one? There we go. Sneak it in. Sneaky, sneak. Sneaky, sneak. There you go. Good on you. Oh, no, don't move. You disconnect. And I'll get rid of that excess. Use the sucker. Okay. Guess that's connected. That's a pretty meaty solder there. And I'm actually going to take this nub down. Hopefully I don't, well, actually, yeah, I do need to cross over in this area. So reducing this nub down is probably going to help. And I'll float the wire. It'll be up top. Because, yeah, that's going to be a high current wire going through there. All right, and then the other side gets power. And there will be a small wire to go over to here. Or should it go directly to there and then I do... Oh boy, this is tough. A lot of stuff that I need to connect. Okay, so plug in this cap bank cable. I guess I can unplug the bank of caps actually so I don't have to keep it around. But just, hey, what's up, Banana Boards? Just interviewed for a company who makes big heatsink layers for critical circuit boards. Most of what I know was from you. Thanks. Oh no, did you get fired? I hope it went well. I hope you didn't get totally fired and they didn't laugh about it for like weeks afterwards. This needs to be a big ground because this is part of the loop with the coils. So I can big ground down to that and then I can high voltage straight over to this. This doesn't need to be big. This can be thin. But this needs to be big because this is part of the main loop. How do I achieve this feat of mad engineering? I think I just need to drop in big wire. Just remember the golden rule. Double the heatsink size to what anyone says. It's true. That's true. It's true. So I guess I'm just dropping directly down with just an angle piece, because then I'll bend it over to get to the pin header. Hopefully I don't extrude the pin header. And then there it goes, it's gone. I got let go a year ago. It's been rough. That is, yeah, that's a tough scene. That is a tough scene. It's been several years for me. I wasn't really let go as so much as I was fired out of a cannon into the sun. Too much holding my breath and getting things positioned for it to just go completely sideways. For this stuff, I want to be using the big iron, and I could probably even use a larger iron tip for it. There we go. That. That's our negative connection. And then what am I hitting up against? Am I melting this again? Yeah. Great, just what I wanted to do. Oh no, I'm hitting up against the pin header that I can't see. That's not so much soldering, is it? Okay, let me just clean up this little overrun. There we go. Gotta make sure that top is flat or else things don't fit. Ooh, that's kind of nasty. Well, when we get the other side connected, that'll be a little bit better anchored. This one is going to the pin right there. That's ground. There we go. Just like that. Dog is currently trying to steal my arm for a hug. We've got some of that kind of dog around here, and they're so affectionate. It's crazy. When we do our tricks, I go, I'm going to give my puppy a great big hug. And she just like walks away from me. She's like, all right, screw you. She's just not incredibly affectionate. She can be, though. It's very, very cute. But mostly she's a guard dog. She makes sure that nobody's going to sneak up on us ever. I should probably plug the rest of the board into this just so that it's sinking the heat of the header and it doesn't walk around. And unfortunately, this is going to get a little tight. I didn't want this to happen like this. If I did have room to have the plugs come in at 90 degrees, it would have been a lot more organized. But I have them flat, and so when they're flat, you've got power, ground, and it's like alternating. I have a pit mix. He's the most loving animal I've ever seen. Yeah, Willow is not incredibly... I mean, she does in her own way, right? She'll sit at your foot, and that's as affectionate as it's going to get. She's not an incredibly affectionate puppy dog, but she's kind of warming up. She's warming up to it. Let's see. So we need to get from... Did I make a big mistake? I think I did. No, this is ground. That's right. We're grounding stuff still. So the next ground is over here. And it's going to be... Well, no, this one is the monitor. That's the monitor. It's also the low voltage input, but this is ground. This ground? This is ground. Oh, that's right. That gets connected on demand to this. That's ground. Okay. All right, we're getting there. I could do a flat wire that goes out, down, and across. That may be the better way to do it. Yeah, that'll be a good way to do it. That'll give us a nice thick ground for our thick grounding needs. I got a sickness for this thickness. And that is here. So let me just put a little kink in the end. Like that. So that I can get over to this. Of course, the thicker wire doesn't want to cooperate. I'll tin the whole end, and then it'll just be like a drop-in kind of thing. Can't see. I don't have depth perception right now. Why is it moving in incomprehensible ways? There we go. Okay. It's like walking all over the place. It's like, just stay still. 1 second. It's completely off. I wanted it to be taller. Hold on. Further up, rather. Of course, now there's a permanent bend in it. Too big. This thing will help. This will help. This will help. Big flat pliers with their big flat opening. There we go. So push that down, and then right here, grab it right there. Ish. Come on. All right, a little further down. And then it's not long enough. No, it is long enough. I just need to get the rest of the jacket off of it. So our circuit path is through this big ground, through the tip 122, and then back to the high voltage power supply, which is also connected to the capacitor bank, which is also connected to the coil. I think that's all correct so far. We'll check over again, and I'll do a sanity check once we get more of this stuff wired up. We get more flyered up. I think part of the reason that my dog isn't very affectionate is that I am very affectionate. And so she just doesn't feel the need to do that when I'm always like, look at the puppy, I can give her kisses. She's like, ah, crap, here he comes again. Like, but she's not a lap dog. She'll sit at your feet and guard you, which I think is the highest compliment she gives. And like when we're talking with neighbors and stuff outside with all the dogs running around, she takes it on herself to kind of get to the border of where the dogs and the people are and looks out and guards. Very herder instinct sort of thing. This herding breed, this Welsh herding breed. Where did my wire, is that, okay, it is in there. I was like, I thought I saw a gap there and I was like, how's that even possible? Do I need to fully solder this down? Probably not. Hit up a couple strategic areas. So the loop is, it's never lupus. No, I mean the loop is from the positive and negative here, we are connecting this leg to negative. So that leads us back to that. The positive of this is going here through nothing, and so that should also be a big line, which currently it is nothing. Good day to you, sir. So big line from here to here, and then, well, that's right there. So it's already a small line from there to there is also necessary. So should we do that? We should do that above. We'll do that above, and we'll have the yellow wire plainly visible. Big old yellow wire just directly on top of this thing, and then I can run the two little wires from here over to the directly to the capacitor wires. So this, I mean, save for connecting to the rest of this, maybe I can solder this like this and just, oh, my hand's cramping up. Cool. Ah, okay, there's the diabetes. The hand cramps, muscles can get kind of crampy when your glucose level tanks. If I turn on my blood glucose overlay, where is that? Get that to load. Ah, it's not too bad. It's not a big spike. I guess I didn't go that hyperglycemic. I had noodles for lunch, and I gave a lot of insulin for them, but I guess it just didn't react as much. But yeah, so when the glucose level does a big shift from high to low, low to high, usually high to low causes me to get a lot of muscle cramps. It's that whole lactic acid buildup. Some kind of horrific metabolic process going on. By horrific, I mean totally normal. Oh, that was a thought. I guess grocery shopping happened. We're poor now. It's all the money went to the groceries. So do I want to do this across the top, or should I go underneath? I already kind of spent my my underneath budget here. Going from here to, I think, where did I go? What did I do? Are you my son? Wait a minute. That one goes to positive. This one goes, it really should only go up and over, to be honest. What did I do? Oh, I didn't go anywhere with it. Okay, yeah. So positive to positive needs to be a big wire. And it's always connected, except, no, that's not, this one is not connected. This one's connected up here. Yeah, right, okay. I'm getting it. I'm slowly, my brain is starting to form the pathways that should exist in a normal brain, but for some reason are stunted and weird in mine. I will go up and over across these leads on this line because I've already got something kind of sneaking its way around. I don't think there's a good way for me to get a big wire. I mean, unless I go out and over and up, but that's too much wire. I want to minimize these wires. So we're just going to go straight up and over to our buddy over here. So that'll be there. And I guess I could push it out a little bit. No, because this is in the way. That's right. I keep forgetting that this pin header is right here. It's blending in with all the shadows that I'm casting on this thing. Okay. I've got my motivation. I've got my motivation now. So we're going over that way. And down. I've made a little set of Amogus legs. And actually, that will clip here. I'll take this little core sample, that, and bend you back into foot direction. It's too tall. A little bit more. Ever present, quiet chat. Quiet Friday chat today. Shouldn't complain. Well, it's good though because I need to do this properly, so I need to really think about what I'm doing. These are still uneven, but I'm just going to live with it. Let me actually straighten this one out. You don't get a lot of bends with this metal. This metal's very, very cheap. All right, and then tin this so that it drops down quickly and solders. I hope I don't have another incident like the one earlier where I bent it once and it just broke, like straight up. All right, a little bit of pre-tin on that so that we don't melt the jacket too much, because this is it's important for this one to be very, very protected, because this is a high voltage line. This is 100 volts being dropped in. And it's one of the primary circuits on this thing. It's one of the primary loops. Doing the connectors on the side like this may be convenient for like operating it, but for wiring it, it's hell. It's utter hell, and I should have had them in a small line of connectors instead of like this. Would have been a much better idea. Yeah, it's like I can have all my regrets, or I can actually get the circuit wired. This area sucks. I've been bumping my iron into everything, melting everything. It's terrible. All the plastic in this area is just nasty. Had to be a better way. Uh-oh, something just dropped upstairs and there's a lot of Uggs going around. I don't know what just happened. Something heavy dropped down and probably broke. Oh boy. This isn't even, that's not even soldered. And look at how harassed that's looking. God, how do I do this? Will your NDA ever drop off? What are we talking about? NDA for what? for the IED position. That's not an NDA. I'm afraid that's a security clearance. There's no NDA agreement on that one. That's FOIA requests that you would have to do. No, that ain't no weak ass NDA. That's like big boy secret clearance shit. Yeah, the what happens is the jacket is under pressure when you bend it, and so when you do something like this, it'll then yeah, get all greasy. I don't know, maybe I should just remove the whole jacket. Maybe I should just pull that off, because that'll make soldering it a little easier. Isn't it like 25 years disclosure? So we're still a couple of years out from me being able to talk. Not that, yeah, but then again, I don't even know the individual classification levels of some of the information. So now there's just not, I'm just never going to talk about it. Easier that way, my friend, easier that way. Lady never asks and a gentleman never tells. And a government doesn't get involved. This is like harder to solder than a lot of stuff that I've been doing lately. The problem is all this plastic in the area, and you can see that I've like melted a bunch of this away. I'm not proud of that. And I've definitely melted a bunch of the plastic over here too. And I've got to somehow maneuver the iron in to get this thing put right there without shorting anything out. It's just a big pain in the butt. Well, attempt number 2. I don't really have a lot of control over this as part of the problem. Not what I wanted. This is what you want. This is what you get. This is what you want. This is what you get. Okay. All right. Nothing is cooperating. Okay, that's a little better. That gets one of the legs at least attached somewhat. And I can kind of, but the problem is I'm going to end up bending it and this will end up breaking off. Yeah, it's already there. There it goes. Son of a bitch. If you go out and around, nah, this will work. I'll get this to work. The shape of this thing is very annoying. Oh my god. Okay, do this, then drop it straight down, solder on, and then it moves because it didn't solder on or I didn't hold it there long enough. Oh my god. Okay, I'm very, very mad. Let's see if we can rein this in a little bit, because it's like it's just not cooperating. None of it is cooperating. Now this piece of wire is okay. Throwing that out. Starting again. We're gonna figure this out. I need an entirely new piece. God damn, that was frustrating. A little piece like that. Then we go horizontally. That's actually too far of a drop. No, I can make that work. Pretty tall, but should be okay. Over to there. And then this tiny little bit out there. Strip it again. Definition of madness, right? Doing the same thing and expecting different results. one of its pant legs is going to be a little bit short. All right, and then pre-tin the ends. And the wire's going to get all goopy when I do that. We're almost there. We're almost there, chat. We're almost there. We can see if my scheme was so harebrained after all. What? You saw, look at that. I'm so tempted just to use wire. If this stuff is going to do that, what's the point of it? Like, maybe we should just use a piece of wire. This is 28 gauge though. That's not enough wire. I need the big thick stuff. So, do I suffer through on my leads melting like this and just do it? Or should I find a thick sheet of silicon jacketed wire, like something 18 gauge maybe, and just put a little piece of wire in there? Or do I re-strategize the whole thing and figure out another way to do it? I mean, I guess what I can do is get the jacket off of the end of this, the ugly part. Oh yeah, I wonder how the stuff in the crock pot's doing. I put ribs in the crock pot this morning. The new one, we got a Cuisinart instead of a crock pot. Because the crock pots, apparently they added like 20 degrees to them. So apparently the low setting was like overcooking stuff. I don't really know, but this one is, people have recommended this brand. I mean, Cuisinart's a known brand. You know, people know them. But still, it's like, this is way too long. What am I doing? What are we doing here? What the hell? This sucks. I'm getting a big piece of wire. I'm going to put a big piece of wire and go in this little corridor here, and we're just going to loop it around. God damn it. I had my friend make a crock pot into a sous vide. We have a little sous vide thing, and it's got a little water pump in it, which helps that out a lot. But sous vide is awesome. Yeah, I mean, our crock pot, it's okay. I feel like there's a particular flavor to it. There's something about the way that it handles the fat that makes it have a particular taste. Specifically the crock pot. I don't know. We're going to see if the Cuisinart is any different, though. I mean, I could get a little piece of tubing and use that too, but I don't think we're pushing that much current. Yeah, I'll just use this stuff. This is 18 gauge, but it's also silicon jacketed, so if it gets hot, it should be okay with it. Maybe. And that way I can take the more circuitous route, and I can also be rest assured that my wire isn't going to blow up with this sudden inrush. That may be too much. I wonder if the 20 AWG could take it. No, I'd better... I don't know. What do you guys think? You guys just want stuff to blow up. It is such a small length. And this stuff is a lot thicker than I thought. And if I go in this direction, it should probably be slightly smaller. But going to 28 gauge might mean that it's a little volatile. That's pretty decent. Yeah, we'll use this stuff. Oh, really? Really? Okay, good. He says to his reel, really? You guys get it. Purchased a new house about a year ago. Oh, congrats. They left a 3-bowl crock pot in the pantry. I haven't pulled it out, but it looks brand new. A 3-bowl crock pot? Huh. Yeah, ours was, so... Ours has the giant ceramic insert. It's not really all that necessary, let's be honest. As long as there's a good heater on the pot, I don't think having a big ceramic bowl as part of your crock pot is really all that necessary. It's there for the temperature stability and everything, but it makes cleaning it a huge hassle. No, you talk. Talk all you talk. I said that last stream. I do not mind if I'm only talking to one person. It's okay. Because things get quiet here because I'm doing, you know, actual work. And we have a number of viewers, but it always feels a little weird when you're just talking to one person from the chatting perspective. And look, I know what that's like, and it's totally cool that you do that. I appreciate it. It keeps the stream moving. This is going to be a hassle when I have to solder this over to that, but I think I can do it on the other side of the board, just connecting this giant thing. Let's actually let's do the low voltage, or the low current connection. I mean, this will also be where it blows up, so I don't know. Sorry, I'm just thinking. I just got to think about this for a second. Oh yeah, this needs to be pushed down. All right. So, I'm on vacation today. I'm doing the same thing I would do if I was working. This is a great place to come in and distract the streamer. How dare you? I'm thinking about what I want from this area here, because we need to have a big connection from here to here. And if I come back in, I want this to be connected to here, and I want to give this plenty of space to blow up if it needs to, right? So jumping over to there, just straight up above the board, really is the best way for me to do this, even though it is a little bit dramatic. So I have to make the Amogus jump work, my little Amogus shaped jumper. So what I'm going to do is I'm going to do the small wire here, and that'll sit under the things, and so I can then clip that just right at the transistor. And that's our connection to 100 volts with only 80 milliamps. And this thing can handle up to 600, sorry. 600 at 160 volts. And I'm hoping that the reverse current protection is going to be large enough that the big loop can happen and it doesn't explode. Because it's designed for driving like lamps and stuff. It's just for high voltage stuff. So that's that. Now I need to go big from one end to the other, and I need to, I guess, bend up a little thing again, because the wire's all too thick, and it's going to get in the way of everything. And I need this tiny little jump out of it. Once we do that, I can, I guess, build the rest of this thing and be done with it. Actually, what if I use a component lead? Is that going to take enough current? Technically, that's a 1/4 watt, but it might just tough it out. No, this is a bad idea. Unless I can find a component lead that's big. Hold on a second. We're having bad ideas at a faster rate. Now, you're an RC guy. Any thoughts on LiPo care for longevity if you don't do big discharge cycles? Get it to 80%. You can get chargers that have a storage charge ability. And I probably need to do that with a couple of the chargers that I have. We're going to pull the legs off of a bug here. We're going to pull the legs off of a bug. How about some of these? Because I never use these guys, and I've got actually, I've got a couple of them down there. Hold on, let me grab the component down here. I've got some of these big transistor guys, and they got huge leads on them, and I don't have a job for them. I never use them for anything, so we can use one of the leads off of that, and that'll give us a nice thick wire for our high current connection. But yeah, the chargers, there are chargers that have like a storage charge, and sometimes that'll be in like the discharge menu. And you can also buy stuff that will take, I used to have this little green plastic puck that you would plug the battery into, and it would take it down to 80%. You know, when I need the thing, I don't know where it is. That's how it always goes with this stuff. I think it's down here. There was like a bag that had 3 like huge transistory kind of Jiminy Johns in it. These are the diodes, zip ties. No, they're there. I don't know what these are or what I bought them for. Schottky diode. TO247. They're 100 volts and 60 amps. These are big motor diodes. We don't need the diode. I just need the leads coming off of it. And I'll use that to bend into shape to make our little jump. I have a smart charger, just not sure if I should charge to 100 after storage. If I'm only going to use 15%. Well, there's a quiescent current that's inside of the batteries, but when you buy lithium-ion cells, they're usually at 80%. And I think that's what the storage is. And don't trust a Twitch streamer to give you good advice on that. Look it up online. But generally, that's what the storage cycle is there for. It's to discharge your battery to a percentage that will allow you to keep it for long amounts of time. Do electric RC cars beat nitro cars, or are they completely different? They're different, but I think nowadays, you know, I can't really say. I don't really know. There is an answer. I just don't have it. Electric has come quite a long way and become more viable than it used to be. Which overrun is there going to be? I think that's about right. I'll use this to bend. Oh, please. Please, sir. That, and it'll just be this big staple that'll sit on top of everything. I only trust Twitch streamer for my knowledge. How can get answer to question if not ask Twitch streamer? Streamer knows all. I don't know if this is going to work. I could do it like this, where it's like sideways, bent a little bit. No, I can bend that a little bit of that end. Would rather ask a human with experience. Yeah, I mean, you know, take the information that I give you with a grain of salt and maybe make an informed search afterwards. That's kind of what I'm advocating here. Is there's my initial answer. Maybe that gives you a couple ideas of what to look for. But generally, like oh damn it, I just bent it the wrong way. Hit the wrong side of it. Yeah, this is bad. Okay, I could maybe make this work. Generally with well, different cells are going to have different storage charges in terms of like what the material is that the battery's made of. So lithium ion, I think, is 80%. I don't know what the others are. But yeah, a good charger should have all those settings, and not like the charger that you take with you and charge between runs. It's like the really good charger, the one that you have at home specifically for storing and stuff. That's a little close. All right, that one was too close for comfort. Let's see if I could try again with this. Already ruined the Schottky diode anyway. I need a better measurement of the distance between these things so that I can get this right. Like edge to edge. Ace to ace. Okay, it's a very small overrun there. Bro Guts, I don't usually get to catch you live. Wanted to let you know that watching your streams gave me the confidence to start building and soldering stuff. Hey, I'm working on a video synth and effect system on weekends. That's cool. I do know that Speedy Cat had a bunch of video synth stuff that he was going to send in. I never got an opportunity to receive any of it, but it does sound interesting that you can do the sort of modular synthesizer stuff with the video. That sounds super cool. Hey, but I'm glad my stream gave you a little bit of confidence. We do like, you know, the stuff we do, but I just feel it bears repeating. We do more like cerebral sort of actual smart projects around here, and that takes time, and we don't get a lot of good. I don't especially get a lot of positive feedback that I'm doing the right thing, you know, because I'm out here on my own, and then I fail at something, and I'm just like, ugh. So nice to get a little positive word. All right, so I've bent this into what is essentially a staple shape. We'll see, because this thing will take solder much easier than the other ones. And this will be our sort of high current bar. Ah, that one's actually the right distance. Perfect. Using that measuring tool was perfect. Yeah, look at that. Beautiful. Beautiful. I did not make this connection over here though. So that's one that we need to make. So let's move this before we solder it down, and I will put just a little piece of wire right there. After getting my finger oils all over it. This is a busy part of the board, huh? I kind of did this to myself though. So once we get this stuff soldered, all we have to do is do the voltage meter, and then we're ready to test. Hard to tell what videos are actual opinion or paid promotion at this point. What? Oh, you mean for the, Look for the oldest looking website you can. Or do a site, reddit.com, which is an unfortunate thing that we have to live with these days. Yeah, I hear you on that. That's tough. How do you get around that? Certainly not random YouTube videos, but because those are all going to be paid. But if you find like an RC car forum, maybe. What's your source? I saw it in a dream. I learned it from a streamer. This is really not working out the way that I wanted it to, huh? I can't get the solder to like do anything sensible over here. It's not coating the wire. The wire is just there. It just happens to be participating. If I hit it with just a little bit of flux. Yep. Is that gonna coat the area and maybe make this work? I have to come down from an extremely high angle on this too. Probably should have done this part first. There it is. Everybody cooperates. Nicey nice. Let's get rid of some of that solder there. So we're a little cleaner. I want big gross solder blobs all over. And I want to make sure that this is soldering over here. It doesn't look like it is. I should see solder coming out of there and not that strong black line right there. It should look a little bit more flowy like its buddy over on this side. We're making a mess again? Yeah. This is the second build of this because I went a little bit insane and I decided to redo the whole thing just because it wasn't the way I wanted it to be. That's probably drippy at the bottom. It's probably dripping down the bottom. I can't see what I'm doing because I have to come in at such a high angle. That feels a little bit more soldered to me. All right, now where'd the staple go? There it is. Nope, wait, yep, okay, that's it. Staple, staple. We're almost there. I got a couple more connections to make. This is unfortunately a little bit sloppy, this positive power bar. I can solder the ends of this so it goes down a little easier. This is just going to be our high current connection between the two banks of stuff. We'll have to see what heats up when on this whole build. This stuff takes solder really easily. There you go. It's all tinned up. Tinned up and ready to mingle. I want to to give this a slightly lower bend. A bit more, a little bit more. Okay, so that'll go in on top of these two, plus the two together. This is one of our primary current paths of the whole thing. A lot of current running through this bar, and I need to make sure that it's out of the way and that it conducts properly and it doesn't short anything out. It would be a terrible, terrible prank if this thing shorted. Can't touch it with my hands because the whole thing's going to get too hot. It already is. Owie, owie, owie. Ouchie, ouchie, ouchie. My tweezers are getting warm. Okay, here. I'm going to move it over a little bit. And I've done that before, using the tweezers as a jumper, temporary jumper. Fun times. It's always a little nasty when you do that, though. Press down on this. We'll inspect the work in a minute. Okay, I'm going to leave that a little crooked. It's fine. It's fine. Would have not thought to use a staple. Well, the problem with the staple is that I could come back at a later date and push down on this and it will short out to whatever's around it. It's kind of a little bit of a, I was backed into a corner and had to do this. Typical circuit stuff, I don't know if I would rely on it, although this is pretty thick wire and it is pretty well mounted on there. So, but the problem is now I have this 100-volt bar sitting right on my circuit. Okay, so here's what happens. Time is equal to 0. There's no current on this positive pin right here. That positive pin is connected to the FET, or the whatever it is, the SN5551, right? SN5551, it's connected over to it, ground going over to there, nothing is charged, nothing is happening. When we go to fire off a shot, let me get the light closer. We actually see something without blowing out our eyes. Maybe we can get a little further away. This is as far away as we can get. Okay, so we decide that we would like to shoot our shot. So we send a 3.3 volt signal from D3 up here through the resistor that keeps it in check, and then into, that looks like a cold joint. I think it's okay, but it just looks a little weird. Anyway, we send it into here, and then that turns on the 100 volts. So now we have 100 volts coming on this line right here. This is only connected to the collector, which is pin 3. Let's double check. Should have mentioned use some heat sink at the risk of shorting out. Wait, what? Oh, use heat shrink if there's the risk of it shorting out in the future. I was melting the wires on stuff and I just wanted to get this done. Like, it's just one of those things. Oh, this is Sky Rizzy. This has nothing to do with, this is the Rizin Kism Ma Rizza. Stupidest medication name. Anyway, over here. 5551. Pin 3 is the collector. So we have 100 volts on the collector. We have a 3 volt through 1K on the base, which is pin 1. Yep, that's correct. Base pin 1, 1K going over to D3. And then the emitter is here. So when we go to shoot our shot, we activate this transistor, current flows through, we get 100 volts on the positive green wire, which leads to the coil, and then the positive green wire, which leads to positive on the capacitor. The capacitor's ground is also connected to ground. so that we have a full current loop going through our capacitors. So we are charging them at 100 volts. Now I'm going to work in the voltmeter in just a minute here. But before we get to that, we then want to shoot our shot. So we turn this off, we turn this off. 100 volts is being held at the capacitors here, and our tip 122 is connected to D1, right through that 1K. It is also connected on its collector to the negative lead of the coil. Negative lead of the coil skips over there because it's only connected to the center pin of my big 3-pin thing. This is just a little bit awkward. The wire broke, but I soldered it anyway. So this is the negative lead here that goes to the collector. The emitter goes directly to ground. And that ground is also grounded with a bunch of the other grounds and the high voltage ground. So when that connects, the circuit loop is positive to the positive end of the coil, down through the tip 122, back to the negative of the capacitor. When the coil shuts off, on the positive lead of the coil, we get a strong negative, and so that will filter its way through this giant, this is a switching diode. It would be better as a Schottky diode, but I didn't have any that were over 100 volts. So this is a 1,000 volt tolerating 3 amp flyback diode. And that should dissipate all of that excess negative current and allow it to go away. And so, you know, this little guy right here might get warm, but this thing is rated at 600 milliamps. This power supply is only able to make 80 milliamps. Why male models? Modeling just sucks. Modeling just sucks. They made me take off my top. Handsome Boy Modeling School. I should watch the show that came from, because apparently the show is pretty funny. I just never watched it. There's like a, I don't know, like a quick thing. I don't know, I forget what it was. This is looking pretty slow, or pretty sloppy rather. Sloppy, same thing. Okay, so let's hook up the voltmeter now. So I'm just gonna do a red and a black wire, and I'm just gonna, you know, hook them up. That's all it takes for this thing. The voltmeter doesn't use current. Answer my boy modeling school. Maybe the model I am today, and hopefully tomorrow. I used to listen to that album in the car, so I got it like memorized. One of those albums, 2 of those albums actually. There are a bunch of Handsome Boy Modeling Schools. I remember them. I hope this thing works. Better work. Okay, plug this thing in. This red wire here. Oh, that's ground. That one is ground. Oh ho ho. Hold on, what do we got on the top side? Okay, so there's not a lot going on up top, which is good. And I guess I could just run a wire directly over to this ground over here. I mean, they're the same ground. I would just be measuring it from the other side, and I don't know if that opens it up to a potential for, like, I don't think it will. Everything is sharing the same ground on this circuit, which is a little concerning when we're dealing with, like, isolated voltages and stuff. But I guess I could just learn to live with it. This ground connecting to, sorry, this one, and that's ground right there. But I need a wire to come out of here so that I can connect the ground at all. So I guess I'll just do wire on this. Yeah, we'll just have a little piece of wire. It'll be very tiny and short and adorable. I do want to test this, and we're running out of time, so maybe I'll just be a little bit late today. I'll run late, stream for you guys. Because if there's, like, I don't know, having high voltage and low voltage all on the same ground. It just doesn't feel right to me. That's all. Feels like it's an accident waiting to happen. Shorter. This is going to bend the wire a little too much. Wiring's looking pretty excellent. It leaves a lot to be desired. I think it's just the arrangement of these elements makes it feel very sloppy to me. Ah! Can it blow? I just have no idea why. I would need to put my thoughts together a little bit more. It feels wrong is not very much of an explanation from your intrepid streamer, but having a common ground on the high and low voltage stuff, it just, I don't know, it feels like the high voltage stuff might be able to filter or release more noise and stuff into your circuit that would be undesirable in the low voltage area. I don't work with high voltage a lot, that's the other thing. So I don't really know all of these specific precautions that I should. Yeah, like analog and digital ground can have bad interactions with one another. And a lot of the high voltage stuff is analog. Similarly, isolating like current grounds, high current ground. But maybe it'll all be fine. That's what I'm banking on. Not blown up anything yet. Many years ago in DeVry, students all had to put together a frequency generator kit using many discrete components. The student thought it would be fun to blow the big electrolytic cap. Quite a show, but the joke was on them when they found it cost, what the capacitor cost back then. Yeah, one of the big pieces of analog advice that I have to give to people is that if it is the size of a shotgun shell it is. Basically, your big caps hold a lot of energy, and if that energy is being released electrically or explosively, you kind of want to be careful around it. We used to rip the capacitors out of disposable cameras. Those had a pretty sizable cap in there, and you could shock people with it, and people got burns as a result. If you blow up a capacitor, it is a very heavy release of gas, of steam gas. So just be cautioned and warned. The 3 caps that I have here would be a nasty, nasty explosion. That's why I've been sort of careful about them, making sure that everything is done properly. This goes to the power on the cap bank, which is this. Technically, no, I shouldn't do that. I could just jump right over to it. No, I'm going to go below the board. We'll go below board, and I'll bring it over to the positive lead of the capacitor, maybe right here. The whining sound those caps make, too old for old flash cameras and old tube TVs. Yeah, you can hear the sound. How about the thunk of the degauss? Doom. The whining sound, where am I? Hold on. Ooh, that's bad for the wire. That little bend. Oh well, it's done now. Can't undo it. So this is going all the way over here. I really hope this doesn't turn into an explosion of some kind. Trying to keep all the high voltage stuff on one end, but it's I don't know. It all gets really sloppy. This high voltage stuff could have been handled in much less space if I simply allowed myself to have these 3 sticking up at 90 degrees. But I didn't have the board space for that. Bum, 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 bum. What current could those caps discharge? I do not know. I'm not running equations. I'm not running equations right now. I don't know. I wonder what directly causes the whining noise of some of the newer electric cars. It's the fluxes of the coils. And some of them even add noise. But what you're listening to is you're listening to a lot of things happening when you hear the motor noise on modern cars. But what you're hearing is the magnetic fluxes being moved around and activating different coils in a circle. I think I just heard somebody trying to convince the dog to come down and visit me, but she won't because I'm too loud. She likes to sleep during the day. All right, so made a total mess. We're going to clean up a little bit, and then we will test this thing finally. I have all of my connections. We've reviewed the circuit. We know what's connected where. We may not know why, but I guess we'll find out. And hopefully my little scheme of having a transistor in the high voltage path to isolate is good. But we don't test high voltage without cleaning up first in case there's a fire. What are you considering high voltage? Would you have a problem with 5 volt, 12 volt? Anything above 24. 35, I guess, is an okay voltage. But if you get into like stuff that I would count as high voltage, quote unquote, I mean, this is a 100 volt circuit. This is high voltage. I don't care what the internet desinins will tell you from their high chairs, looking at you down their nose, saying, oh, pithy little human, I work in control voltages. I work with 300 volts AC all the time, and I eat batteries and lead for breakfast. I don't care. Anything in the DCs that is above a comfortable level, which is somewhere around 24 volts, then you can consider it to be high voltage, and it's better to treat it as such. I was told 300 volts DC on my old power supply didn't count as high voltage, so I petulantly put a warning on the silk screen that said danger medium voltage. Well, like 300 volts DC is high voltage. I don't care what side of your bread you're buttering. It is dangerous to a person. I'm going to consider it high voltage. Do we check everything over? I think we did. Yeah, it looked good. I don't think I forgot anything. We'll know in a very rapid succession if something is totally wrong. There's your driver's circuit that won't blow you up. Now I'm going to put this down directly on the desk. It'll eventually get standoff so that it can just sit on the desk without being a hazard. I'll just put some stuff away here. 24 and above has the potential of something to watch out for. You're making yourself clear, probably due to experience from the past. All right. Just continue to clean this a little bit. Get everything out of the way. Yeah, like phones are what, 75 volts or something? You can get a pretty mean shock out of that. So, from the wall phone. Let's see, that's garbage. This goes up. Circuit, all these little scraps we got to clean up. Okay, this goes back over there. This goes back. Ah, almost died. .24 volt AC. I've never worked with a lower voltages in AC. AC's always been dangerous voltage for me. Yeah, no dog down here. Sometimes she'll come down and visit. Not that much anymore. She used to spend a lot of time down here. I would be doing work and she'd be just sleeping under the desk. And during stream she would come down here. I don't know when that changed. I think just because the front door has all the action happening. She can view out and see the neighborhood and people walking by and stuff like that. So there's not much of an incentive for her to come down here and hang out, even though it was the best thing ever to have my little puppy dog hanging out with me while I was working. It was the best thing ever. Doesn't happen anymore. Gigantic electrodes in a phone company building. It was 48 DC or something like that, which is huge, such huge current capacity. It would vaporize a 10-inch crescent wrench. Oh my God. That's crazy. Old timers always have the good stories. Old professor was telling me about working at a TV tube company, and they would come off the line extremely hot, but it was all vacuum charged and everything. So if one of these TVs dropped off of the line and they were being suspended like vertically by the end of the tube, so if one of them fell, it would break and then implode and explode everywhere with hot glass. Pretty crazy. All right, so this thing sits way the hell over here, far away from me. Huh, that seems a little weird. Okay, capacitors, check. Solenoid. Why do you say it like that? Why do you say it all weird? Did he say it weird? He said it. Why do you say it weird? And then the voltage meter. And positives are on positives, negatives are on negatives. We're all set to go. Everything properly organized. Yeah, the jump over to the side's a little weird, but I guess it had to happen. You could stand it up. Power supply, turn that on. This is going to be nerve-wracking. The first shot on this thing is nerve-wracking. Oh, and actually, before I even power it up, I need to program the microcontroller with the proper stuff. So D1 was, well, we'll take a look. Hold on. This is all the stuff that this thing is doing. Basically, what this does is it starts up, make sure, sets serial if it needs serial communications. It sets up the Wi-Fi and connects to my local Wi-Fi. It sets up over-the-air programming every loop just to make sure. Then it'll do its initial pin setup, then get up on MQTT settings. Once setup is done, it turns on the LED. Where's our loop? Here's our loop. Our loop's very simple. Check to see if anything's happening on the Wi-Fi. Handle the Arduino over-the-air stuff. Pull the MQTT client to see if anything has changed or needs to change. And then it checks to see whether or not MQTT is done. And it does stuff if MQTT has changed. There we go. That's what it is. Okay. Don't think it'll be long before you hear about techs working on electric cars that should be getting nuked. That's 300 volts on extremely high amps. Yeah. I wonder what kind of, there have to be like safety systems on that get activated when you work on it. Or do you even work on it? You just pull the battery out and then put a new one in? I don't know. I don't know how that works. Take the whole chassis and throw it away and put a whole new one on there? There have to be like safeties that you activate. So we're doing something a little different now. We've added another pin. So our pins currently are the solenoid pin and the enable pin. And the enable pin needs to be changed because it's now directly connected instead of remotely connected. So which one is going where? Well, the firing solenoid is the white wire, which is D2. And then D1 is the charging. Is that the charging? D1 is, yeah, D1 charges D2. So define charge pin D1, solenoid's D2, and enable is D3. 1, 2, 3. 3 fingers on the outlet box and screwdriver fell between the pins. Oh dear God. Certain components are segmented and you can disconnect portions going to certain things like the motor and the other electronics. There are connectors that separate everything. I see. Well, yeah, the one hand rule, right? Okay, so we have a new variable here. We have a new pin in order to allow charging. So when we do the business of firing off the solenoid, we are here. Oh yeah, I need to set up the pins. Wait, the pins need to be set up too. So charge pin, I'm just going to cut that variable, copy that variable. Digital built-in LED. Enable pin is an output. Enable pin needs to go high because that disables that thing. Built-in low, pin mode, charge pin, output, digital right. My 9 key doesn't work. There we go. Charge pin low, because it's an NPN transistor. So digital write charge pin low. We need to make sure that that enable pin is the opposite of what it's doing right now. This is to tell you that it's done doing its stuff. Even though I said to pull it low, I don't know why it illuminates then. Anyway, Wi-Fi connection, enable pin high, delay charge time, solenoid pin high. So in here, oops, no, not all. Don't select all. Geez, digital write charge pin low, and then the enable pin high, charge pin high. Enable and charge high. We're done with our charging. We set that low. We set the solenoid pin at the same moment. I could give these a little bit of time in between, but I don't think I really need to. Delay for the unknown variable that gets passed into the, this is passed in from MQTT. That was one functionality that I wanted to kind of figure out. And then the solenoid pin goes low and the enable pin goes high. This needs to be high because it's for the opto-isolator. You can't have negative light. You can't have negative light, so you don't need to correct me. The digital write would have been caught by the compiler. You can let the compiler catch those things, because then people can see me make these mistakes and they can see how to correct them, because it's just as much of a skill to correct mistakes as it is to make them. I mean, to whatever. So if debug serial print line to no, and if digital write enable pin high, charge pin high, delay for the charge time, digital write the charge pin low, solenoid pin goes high. I could put some delays in there, but I don't know if I really need them. And I think that's it. So we initially set, we also need, we set the initial charge pin state, and we set the enable pin initially low. Enable pin high. Yeah, there we go. High. Everybody else is low because they go into NPN transistors, and the TIP 122 is NPN as well. So we're ready to program. So let me get the programming cable from behind the thing over here where I hide it. We can do our initial test, and really, hopefully, nothing explodes. The circuit is as easy as can be. I unfortunately could not have built it as simple looking as this diagram is. This diagram is so very, very simple. All it is basically all my stuff is connected to high voltage. I apply high voltage with a 5551 because previously we saw 9 volts over here. Since this is only 80 milliamps, the 5551 should not explode, and it should pretty much just work exactly the same way that it did before. You send current down through there, and that'll allow 100 volts down on the line. That 100 volts charges up in our big cap bank, which is always connected to ground. Once we're done charging, we can turn this off and we can turn this off so that this will just kind of sit at a weird voltage. And then we fire this one, and when we do that, current is allowed to go down through the coil. And then once it's done, the magnetic field dissipates and current will go back through our flyback diode, through the flyback diode. And that's all she wrote. That's basically it. So, what up, Kavorka? I have a 1200 watt microwave in the trunk of my car. 0 to 1 AWG wire from the back. What? Sounds nasty. What are you gonna make, a big microwave gun? Shoot the neighbors? Okay, so this will be a big nasty clunk. Hopefully no pops or banging noises. I'm gonna keep these caps away from me. And that's our circuit. Let's program it. I keep forgetting to program it. I got the wire over here and then I put it away again. What am I, stupid? Okay, so plug in the Arduino, and then we can, I probably could do it over the air, but I'll just do it like this. This will also check to see that our Arduino actually works. I could probably restart this computer, or sorry, restart Arduino, and there wouldn't be all of these other IP addresses. I don't know what, wait, 300S for 3 seconds? 1500-watt inverter. Oh my God. All right, let's upload the code, see if there's any little errors. Hey, it's very simple Arduino stuff that we're doing. The state of all that stuff is going to flip pretty quickly, too. What is this doing? Is this compiling? Oh, there it goes. Okay. The Wemos D1 Mini Lite. Even the Mini Lite is fast enough to get on Wi-Fi and join MQTT shenanigans. What? Why? Why is that? Wait, why would you do that? For a microwave? Weird. Sister company I work for has this CAR electronic device. You can say it's welding wire used to power it up at 600 volt DC, 50 amps. Jeez. Those guys who did like the FBI trucks were dealing with stuff like that. They had some pretty high power RF stuff in those black vans. I don't know what that fully entailed either. They had some crazy shit going on with the wiring. Oh, so they were complaining you were running up the stairs, so you got a microwave in the car so that you could microwave things in the car. I thought it was something weirder. I don't know why you need to. Okay, anyway, let's test this thing and make sure that the whole thing doesn't heat up and explode. I am a little bit nervous about this because, I mean, you guys saw me. I just finished building it. Connect this to the power supply. Power supply is connected over here. None of this stuff should get hot. None of it. None of it. Not even a little. Hold on, let's just rein it in a little bit here. We're going to do this in just a minute. Power it up. The breadboard circuit worked just fine, and that was even worse than this. So really, to be fair, this should just kind of pop off. Everything should just work. But it's one of those situations where we're dealing with a lot of volts, and anything that I've forgotten to do is going to come to fruition. Make sure the thermals get a good view of everybody. The idea light a little closer. There we go. Yeah, everybody gather around for what is sure to be big fucking pop noise. Are you guys ready? 3, 2, 1. This is where I hear a deafening pow and everything stops working. It is currently drawing 0.1 amp. I don't see anything really happening. So the next question is, if I type an awe emote, I'm backing away from this, by the way. 3, 2, 1, go. All right, something else isn't happening. Whew. Creepy. High voltage is creepy. Jesus Christ, don't do that. Make my heart fucking skip into my throat. Remember to breathe. This is drawing 0.1 amp. And the 100 volt supply appears to be getting warm where it should be getting. I'm not going to poke that for sure. The Arduino is not generating any heat. I don't think it's turning on. All right, so turn the power supply off. Why would Arduino not be playing? That's connected there on the center pin, which is also connected to that capacitor. That's ground on that pin. That should be working. That should be generating 5 volts. I mean, I guess I can poke this with a multimeter, but I was hoping I didn't have to do that. It appears like the Arduino is not coming up to power. I don't see any reason software-wise why that wouldn't be happening. And this is a 5-volt 1117. It's not. It's a 3-volt. Double check that. Oh, AMS 1117, 3.3. Oh, okay. So we're just going to skip over that 5-volt and go all the way over here to that first pin. No, I don't think there's anything crazy going on here. There's that one big capacitor, but I think I can unplug everyone and do the quick little soldering that we need to do. I put a 3-volt regulator on here and I didn't realize. So I am simply going to snippy snip. Where's my snippies? Cut the red wire. Red wire gone. And then we'll put in... You missed me having run a 3-volt regulator into a 5-volt pin. So nothing happened. It didn't power up, which means nothing charged. So it was pretty much, it wasn't a wet fart. Wet farts are more exciting than what happened. It was just simply a no launch. No launch. Oh, that's going to burn me if I'm not careful. We just need to run our output a little bit further so that we can get it to the 3-volt pin. Oh, and this thing needs to be on. Okay. And then, why is it catching everything? Let's take, it's still a red wire. We'll use red again. Oh my god, this is becoming a bird's nest. I need to respool these. This is so much wire. I mean, jeez. Order it once and then never again do you ever need wire. Too many things passing over each other in this circuit, in my opinion. Feels like it should be able to be done much cleanerly. I'm doing this from a distance, so I can't really see what I'm doing. There we go. I almost stabbed the whole spool with my solder. It's always embarrassing. Wish I do, wish I do. So over to there, and then there. We'll thread the needle through here. Go over to this bottom pin over here. Thread the needle. It's a bits redeem. It's not a command. Okay. All right. So then that just drops down to our 3-volt. So we're bypassing the regulator in the Arduino, in the D1 Mini. There it is. Tear down the flexi lead filament I mentioned earlier. I want to know if we can cut it to length or not. Huh? Do a teardown of the flexi LED filament I mentioned earlier. I want to know if it can cut to length or not. Oh, I don't know. I don't know how that stuff works. Okay, so let's quickly get this thing soldered, and then we can finally test it. I don't know. It's like, why are you derailing me? Jeez. You guys got to Google stuff every now and then. You got to look it up. I'm blaming you. Don't pass the buck. I'm not Ask Jeeves, man. Shit. All right. Okay, so now this is connected to 3 volts. It should power up just fine now. Or blow up. I don't know, whichever. Any outcome in a storm. Capacitor bank with the big guy. Solenoid with the big guy. Voltmeter with the little one. Pluses and minuses are all set. We checked over our work a couple times. Why did I just hear like a wet, weird noise? That might be my insulin pump doing weird stuff. Okay, so that's all connected, and now our power the regulator should probably get warm. This keeps bugging me. These 2 wires want to take a completely different path. They're so light. All right, so everybody's hooked up now to the proper voltages. I got my regulators wrong. I got the wrong voltage. We don't need 5 volts in the circuit at all. Even though I was going to rely on the Arduino's internal regulator, we're just bypassing it. These, I don't know what the size is. These are 1500 microfarads, and I think they're 200 volts. So, and we're charging them to 100. That would have been an unfun thing. So my biggest concern about this circuit is what's happening when we actually fire off the coil. We are relying on some pretty low current connectors. I think these can handle an amp usually, but these JSTs are not exactly equipped with a lot of metal in the connector itself. So we're going to keep kind of a wary eye on the temperatures of the connectors as this thing works. But let's just see if we can get it to pop off at all. I'm going to plug it in. The power supply is still off. And when I turn it on, we are going to very carefully observe what heats up, about whether or not I need to turn it off again immediately afterwards. But we had it working before, so 3, 2, 1, go. And the power supply is getting pretty hot. But our LED's on, so that's working. Okay, test number 2 is when there is an awe emote in the Twitch chat. I'm backing away from my desk right now. 3, 2, 1, go. Okay. So we didn't give it enough time to charge, maybe. I mean, before 500 was the right amount, but we're hitting it with 3 volts, and that might not be giving it too much of an opportunity to pop off. 3, 2, 1, go. You see that? It's just barely like, I don't know. Do you think, so is it the transistor not flipping? Let's see here. So let's look at the code. And if we do the enable pin high, because maybe we need to have 100 volts there, but it would have 100 volts there before it charges. So that's what we're looking at. The voltmeter is always connected. We are looking at the voltage on those. Enable pin, charge pin high, charge pin low, solenoid pin high. So charge time. Maybe if we just give it double the amount of time. It could also just be losing all of its stuff through that transistor. So we are enabling, that'll put 100 volts at the gate. Then we're going to make the charge pin high for the amount of time for this. Wait, enable pin low. We're not enabling it. That's what it is. Enable, we didn't change that. So let me get this out of here. We were okay as it was written. Yeah. So, okay. So now we're enabling the power supply. We are opening the NPN transistor. We charge. Then we undo the charging, fire the solenoid. We should actually be doing the enable pin high in that step because the solenoid is the last thing to fire off. So this just does all this stuff at once. It'll be in rapid succession, so it'll seem like it's all happening at once, but I just want to make sure that these are happening in sequence. So the enable pin is enabled. The charge pin is set to high so that the charger is connected to the caps. Then we set the charge pin and the enable pin back. So this one goes low, the other one goes high, and then we fire off the solenoid because we're all charged up. Maybe we should put in a little delay here. We'll just give it like a little 20 millisecond delay right in the middle of that. I know this is arbitrary and it shouldn't be a number, but I'm putting it in there anyway. I just want to give it just a little, it'll go up to 100 volts, hold, and then bang. 20 milliseconds is like nothing though. So I don't know, but well, maybe we don't need it. Maybe we don't need it. Maybe we don't need it. I'll just leave it like this. So board. Now here's where we have to figure out which one it is. So on port, I've got 3 IP addresses because I haven't restarted Arduino in a month. 160, 158. I think it's the higher numbers, but that's the fart box. Wait a minute. I think this thing is 160. It's the larger of the 2 punch boxes because there were 2 devices that I called punch box. One was our initial testing device. And then the other one was the Wemos that we blew up. So it sees both of those on the network. So let's upload to that. Meanwhile, this thing's all charged up and dangerous, sitting on my desk. Sitting here happily programming away when I've got this dangerous weapon sitting right here. Weapon. Uploading. Why does this always take so much time? It should be like, boom. Guess my hardware's only so fast. What's it doing right now? Did that upload? I don't think it did. How do I know? It should say done. Guess it's uploaded. Did I restart it? Reset right here. Back up. All right, let's try. So if I do an all mode, I'm gonna back away a little bit here. Whew. Well, that didn't get up to what I thought it would, and there was a weird noise. Whoa, and I smell something. Power off. Power off. Power off. I think we blew up the transistor. That little spitting noise that I got, and see how we've got like 5 volts on the capacitor right now. The little crunchy noise that I just heard, I think was the transistor blowing up. So I think I'm in the market for a different transistor here. Ooh, I can smell that. Let's look for anything that's been decapped. Still look okay over there. Let me pull the power supply off. I don't like doing this with it live. It's not live, it's off. Everything's off. But I don't like it with that little bit of current in the capacitors. Doesn't look like that blew up. Anything else blow up? Hip 122 looks okay. The voltage regulator, looking a little greasy on one of its leads. That's where all the heat is anyway. There's definitely burnt electronics smell going around though. I'm smelling a kind of smelly smell, kind of a burnt electronicsy kind of smell. The diode looks okay. I think it had to be this transistor. That was sort of the unknown of this whole system, was whether or not this thing could take the heat. I don't know though. Like, it doesn't really look like it blew up. Diode protection on the solenoid. Doesn't look cracked. This is a pretty stinky, pretty smelly kind of thing. Maybe. If it's just that diode, I'd be totally fine with that. It seems like this guy is probably holding us back a lot. There wasn't a whole lot of voltage present on the caps. How are the caps looking? They're cool? Yeah, they're perfectly cool as cucumbers. Well, somebody blowed up. I don't know who. Yeah, we don't have a lot of latent heat. I would have expected it to be like here, but everything is underneath another like module. So, I mean, we've still got heat dissipating from the LM1117. Oh boy. So this is the positive lead. So I've definitely got the diode connected correctly. And this diode is good for 1,000 volts, so it should be totally fine. I feel like it's this. I really do. But it was definitely like a crackly noise that I heard. So I don't know why I can't observe any other like clear damage to something. Well, we can see if the Arduino survived. Although we won't really see anything happening, but if it comes up and the LED flickers the right way. Oh, power has to be on. Dude. Uh-oh. No LED. I think the Arduino's fried. Nope, it's not. Okay. Okay, our 3-volt Arduino is still good. We still got the indicator LED on it. If I run another awe emote, the light emitting transistor, yeah. Well, nothing popped off. Did anything get hot? Just our power supply and our main chip that's up on Wi-Fi. I don't have the 100-volt power supply connected. There's too much smoke smell. All right, so I'm in the market for a different transistor, I guess. I need something else right here. We managed to not blow anything up though, so that's good. So it's either this guy or this guy. Those are our two candidates. So you ran 100 volts through that thing? Yeah. This is the one I happened to choose was the 2N5551. It just happened to be in my little book of transistors. And I chose it on a whim because it said 5551. I said, ha, 555. And so I was like, well, let's look up this transistor and see if I can use it at this voltage. Probably not. I'll probably be looking for transistors all night. 2N5551, NPN, general purpose amplifier. This device is designed for general purpose high voltage amplifiers and gas discharge display drivers. What? It's like exactly what I need. So the 2N5551 is a 160 volt 600 milliamp transistor. Since it's on our high voltage power supply, it really should only be setting current into these caps at, 80 milliamps max. Now, we saw the charging was a little bit slow. It didn't get quite up to 100 volts. So I don't know if that's this thing having some kind of a dropout through the diodes. That could be, but that seems like a pretty big voltage drop. Or it could have been the thing failing miserably and exploding. It could have been either of those. Before, we just had the thing directly connected. We didn't have a transistor in the path. But I was hoping that I could put this thing on there, and then I could activate it. Again, the base to emitter voltage of 1 volt. I hit it with 3 volts through a 100 kilo ohm resistor. So I don't know what could have broken this thing. It probably, I don't know. Hold on, wait. SN5551 Arduino. Base resistors through an SN5551. Trying to power 4 1-watt LEDs and 4 different pins using a 3.5 with a 2N5551. I've trawled the net for information, can't understand, blah, 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 blah. Hope you mean 4 transistors. High voltage, low gain. What? And of course, they don't get an answer. They just get somebody who's deciding to play with their food. I'm afraid you got lost because you're told wrong information. Most Arduino boards run internally at 5 volts. Okay. Well, it turns out their question was exactly what we wanted to hear, but and then they're telling him to use something else. Resistor 470 to 1K is a good choice for the base of the ones that they choose, not for the ones that they don't answer the question. Let's say I have a job that actually requires that transistor, though. 5551, 3.3 volt. Oh, AI is definitely going to have all the answers for me. There's nothing. We're a little bit too crazy, a little bit too weird. I guess I could run the equations, but so you ran 100 volts through this thing, yeah. Yeah, the surge current is probably pretty rough, but this thing is capable of switching 160 and 180 volts. It's just, it would technically be shorted across the capacitors, so that probably didn't help it. Should only be 200. Yeah, what's the 1K on the base through a 3.3 volt system. And then HFE of 250 max. This is 10 milliamp at 5 volts. 10 milliamp at 5 volts. I don't know what I can't do equations when I'm streaming. I now have a Photech SSR 25 double D relay, 3 volt to fire it up to 220. Those are good. Yeah, those are fun. I have some of those. Those are neat. Yeah, I don't know what I'm doing. Transistor switching circuits, I usually just throw them in there. I could probably find a tougher transistor. We sent it through a 1K, so it should be, maybe it's not activating all the way. Maybe it needs to be a little lower than that. Generally, I throw 1Ks at the transistor switches just because that's kind of safe. What resistor did I use? 1K. There's that one right there. 102, 1K. Into the base, and we're pretty sure this one's the collector and this one's the emitter. And the emitter is supposed to just casually charge up the capacitors, which start off as a short circuit, so that could potentially be part of the problem. Sparky, Sparky? No Sparky. Oh, these are discharged. Yeah, they've discharged by now. I have a feeling this is what blew up, and I probably need to find something a little stronger than this, because that inrush current probably killed it. This thing can only do 600 milliamps. The power supply is only rated for 80 milliamps, but I think maybe the capacitor on the power supply could probably be at fault here. Where is that power supply? It's this. The NCH6100HV says up to 95 milliamps at around 90 volts. We're a little bit above that, so we're like 80. And then I don't know what the schematic of this thing is, but there is a stanking large capacitor on it. So it's possible that this capacitor was the harbinger of death, of the doom of my my little transistor. It just got completely destroyed by one cap going bah. Overload prohibited. Good voltage current out of range. Closing in outdoors. DC-DC. Maybe I can find a schematic. What? That's not what my clipboard was. Where'd it go? Lost it. Lost it. Oh, and I also lost my blank Google page. Jeez, I really gotta. Copy. Oh, they don't let me copy. Okay, neat. Schematic. Oh, nope, this is just your own thing. This is not what I was looking for. This is not my beautiful house. Well, they don't really want to share. But it does kind of look like this giant capacitor is connected across the output for stability. I'm all forking bothers still live. I was about to sign off. I'm spooling down here. I can't do math, but ChatGPT says maybe the resistor's too high, causing the voltage to drop and overheating. That doesn't make any sense. If the resistor is too high, that would mean not as many volts are getting to the end point of the circuit, right? Because it's an amplifier transistor. Close enough, Ball's doing well. Okay, I mean, we did okay. I'm terrible at transistor circuits, but I would have done a transistor off the shelf to a MOSFET. Yeah, I don't have a lot of FETs sitting around. That's I don't know. Maybe I do have one somewhere. I have a bunch of triacs and SCRs and stuff like that. I got a lot of weird stuff, but no FETs really. I'd have to look around a little bit and find one. But anyway, the transistor circuit should have been just fine. I mean, maybe if I go down to 200 ohms, that might be okay. Yeah, ChatGPT, I don't think they're well informed. I think it is possible that the resistor is too high, but it's also possible that turning on that transistor, the inrush current was too much for it. We've got a big ass capacitor sitting on the outside of this high voltage section here. And so when that initially connects without that transistor there's probably a huge inrush that doesn't necessarily harm anything. That maybe where we were seeing all of that heat on the lines and stuff is from that initial inrush. Capacitors start as an open circuit, and as you put voltage across them, they'll charge up and, they start as a short circuit. And as they charge up, the charges are gonna fight each other, and then it'll end up looking like an open circuit. And so I was kind of thinking about it as an open circuit, and I wasn't thinking too much about inrushes and things like that. So when we initially connect, that poor little transistor, who's perfectly capable of operating in such a voltage scenario, was sitting in between this massive capacitor and other massive capacitors that were going to get charged from it. So all the energy rushes through that massive capacitor, through our little guy right here who's like, hey, I'm a little resistive. And it just goes, and then you smell burning electronics. I think that's what happened. I will have to find another transistor for this, and maybe next stream we can get this thing running. I don't know if it'll be tomorrow or not. I don't know if it'll be tomorrow. Maybe. It really depends. I think I might not be up to it. Today was a lot. We got through it, and we got the circuit working. I mean, it is doing what we want it to do, and it appears as though my wonderful little Arduino didn't get blown up. The poor little 3-volt D1 Mini Pro that's been sitting in a bin for 7 or 8 years. It did it once, that's good enough. I mean, the solenoid went off, like it went click. Not as click as we would have liked it to, but when we get back to it, we will be able to solve this issue and then get to the mechanical stuff, like throwing in a motor. And then I got to move on to something else because we've been spending way too much time on this. This has taken a lot of time. It's fun. It's a good circuit to do because it's so simple. It's just literally allowing something to connect to ground, and then it pops off. And it surprises you and scares you and makes burning smell. So I had a lot of fun. I don't think I'm going to raid into anybody today. I don't know if we don't have enough people. No, we have plenty of people. It'd be great to throw you guys at somebody, but I don't know. Yeah, it's kind of a quiet Friday. You guys can go find the usual suspects. Some of them are even in chat today. Sounds like all of your projects longer than expected, but fun. I hope so. Yeah, and I don't know. I got to think about doing some more like off hours streams. Maybe we could do something during a different time of day, like at night. But I've, taken care of the dog and everything, and all the people around the house takes my priority, and it takes my focus away from streaming. I would like to get down here during weird times and do some other streams, but yeah, anyway, it's a lot for me to ask for the whole rest of the house to be quiet. I will catch you guys later. Here's the end card. This has Tuesday listed. Tomorrow will be a surprise if it happens. I'm not making any promises. But in the meantime, you guys can check me out on Discord. I will be there through the next couple dog walks that I need to make. And then when we get back together, we get back together. And we'll solve these issues once and for all.